Okay, checking audio. 1, 2, 3. Sounds good. I think we're live. So let's get started. Ladies and gentlemen, this is the Discourager of Hesitancy. Today we are working on our compiler day. Compiler's on Friday, games Monday through Thursday, and we just do some software development. I code and write and talk stream of consciousness until somebody asks a question. So that's what we're doing. We are on compiler, and we are still fairly early into the whole compiler stages. We're not trying to do this fast. We're not trying to do it right. We're trying to explore and have some fun. So I am working on the Tokenizer Generator, which is not necessarily the right way to do it for anybody serious about writing a language, but I wanted to explore some ideas. So that's what we're doing. Now, I have the old text buffer up from last week's game development. So let me bring up a new one. Sorry, I'm running a little bit slow today. The brain hasn't fully engaged. Yesterday was Thanksgiving Day for the United States, and I ate so much food. Ooh, sugar, carbs, all the good stuff. So might be off to a little bit of a slow start this morning while I get warmed up. So I'm gonna open up our VV project, documentation journal. We need our to-do list, and then we need a shell. Make sure that my Git is clean. I don't remember what that was all about. Oh, I just numbered the tests. That's not important. Yeah, literally nothing else. Okay, good. So we have last week. Well, let's see here. Maybe backing up. A tokenizer is a piece of code that iterates through each character in a text file and turns it into chunks, little words and symbols that the parser can then understand. But we're not writing the tokenizer, we're writing a tokenizer generator. So what we do is we take in a file that might look something like, not that one, vv, or vtoke, or let's see, test.vtoke, there we go. Might look something like this. So we have the type of the token. We have actions, which for now are just single characters. So X means discard, L means new line. So we discard white spaces, lines, comments. And then we have KA for keep. That will go away eventually. We'll just keep by default. When you're writing a programming language, you want to keep most of the tokens. In fact, these top 3 are about the ones that you want to get rid of anyways, no matter what. Most of the time. Maybe Python would keep the white space, but only at the starts of lines. So they might even have something like indent. In the case of Python, maybe it'd be something like start of line, white space plus, right? But we're not doing that here. So it's going to take this and the regular expression pattern for each of those tokens, and it will generate code that does that for us. So we're writing code that reads in this configuration and then generates code for our tokenizer, which looks something like vv test parser. This is what's outputted. And this will be full of functions and all the different things we need to do. Now you'll notice that there's a lot of if-defs in here. That's because The other thing we're doing that's really bad if you want to produce working code is every time I come up with an idea for two different things to implement, like, how do you open and read a file with using system, library, or modern C++ calls? How are we iterating over the file? How are we dispatching our DFA states? Are we binding functions, or are we just wrapping them in lambdas? Are we running through the entire text file, saving all of it into a list, and then kicking out the whole list as a batch process? Or are we producing a token when asked for the next one? Okay, all these different things. This one's done. Why have we not marked that it's done? All of these things use all here. Token production. So process lazy has been done until now, when we're going to do it slightly differently. But what we're doing is, when we go from DFA state to DFA state, we can do it by dispatching in a switch statement, or looking up an index in a function array, a function pointer array, or we just have the function pointer directly to the next state. Those are ways we can dispatch our DFAs. But last week we did dispatch goto in our batch process mode, right? So now we enter the process function and we never leave it. We produce every single token with no function calls to states. Now there might be some function calls to some helper functions like start new token, mark new line, those sorts of things. But those also have the option to be introduced as macros, in which case maybe there are no function calls at all once we enter the process. That's the batch process, right? And what we're doing this week is we're going to finally do dispatching with gotos inside the lazy function. So when you ask for a token, it's going to go into this function. Until it produces a token, it won't leave that function. It's not going to call lots of subroutines, other than as described above with some little helper functions. So it should reduce the function call overhead, potentially, although it also makes the size of your function much larger, which could lead to bad instruction caching performance. And the reason we're doing this is so that I can compare all of these different things and measure how much of an effect each factor has on the overall performance. And we'll select, in the end, the ones that give the best performance. I have some intuitions, and we could start measuring some of that now, but I don't want to. We're going to build out all of these and make sure they're all functional. We can build a Tokenizer Generator using 130, 140 different combinations of things, and they will all work. Then we're going to build up a large body of samples to test against, and then we'll profile it. Just run each possible build combination with a timer, and that's it. Oh, good heavens. Once we've done that, we'll have essentially the single fastest file tokenizer I can think of. Then we'll write some wrapping text around that, some wrapping functionality around that. For example, if you're building a compiler, since the tokenization process is very, very linear, it's hard to multi-thread or SIMD that. So instead, what we're going to do is, for every file in the queue, we're going to basically multi-thread the tokenization eventually, and just have it ready to go for you. But that'll be a separate concern. So in this case, we need to start with where the lazy processing happens. I don't think there's a lot that changes except in the compute next token function. Let's see, let's take a look. We're at generating about 2,000 lines of code for some of this stuff. Everything from file IO to string handling to, yeah, our array of states if we're doing the function pointer array. That's all there. Enumerations to help us navigate things. Yep. So we're going to generate even more code, and that's going to be fun. But it should be doable today. A lot of the code we've already written is kind of reusable, like we found out last time. I thought it would take me longer to get the gotos working. And while I work, I'm going to be eating some Thanksgiving desserts, so don't mind me. Okay, so let's get dug in here. So here we are, all the different build switches are here for us to look at. Today we're switching over to lazy and goto. Those are our build targets for now. Some of these things overlap more than others. So like this function pointer bind only matters if we're dispatching a function pointer array or function pointers. So that's not something we're gonna have to check against. We're gonna have both our functions and our macros. The iterator doesn't behave that much different across the two, so I think we're okay there. And the file open doesn't really interact with it at all. So it's mostly lazy and goto, and we'll make sure that the things are working as well. We have some automated testing, which tests lots of different strings, different situations, to make sure things are working. And then there's a Python script that sets up the build parameters, compiles it, runs it, and makes sure that the test execution works as expected. So we can expect some number of errors, some number of warnings, how many tokens, what's the longest token, the number of lines. That just forces it so that there's no optimization, removing things. We can check things and make sure that we're getting the expected results without having to look closely at them. Unless it breaks, then we look closely, because this logs a bunch of stuff that we capture as well. So yeah, that's where we're at. So I think actually we will need to go into tools, test permutations. There's a place where we break out or continue. There we are. Where we say if we're goto and lazy, don't do it. We're going to short that out. That's going to have to stop happening today. Right, so our make file is ready. Our test file is ready. We're going to engineer this so that we get the lazy gotos early. Yep. Let's go ahead and do a clean and debug build real quick, just to make sure we're running. And yeah, like I said, I'm running a little slow today, so might take us a few minutes to get traction and get the brain engaged. Ooh. Ah. Yes. Yes. Okay. So what we're looking at here is inside of assets, code snippets, tokenizer. If we're doing batch processing, and this is all inside of, oh, these are the helper macros, so we'll come back to those as we need to. We're going to start with functions, though. It's a little easier for me to start there. So new line munch. These are all the helper macros if we're using macros. Lazy. So when we begin lazy processing, this is basically the start. We say our line number is this, our character in the line is this, our next state is this. Here we go. If we're dispatching with goto, there is nothing we need to go here. This actually doesn't exist. Good. Set up our text iteration, start a new token, and that's that. Do we have a token? Compute the next token and return whether or not the next token is valid. So that's easy. Next token just returns, so we don't have to change anything there. That's with that. Okay. Oops. Next token doesn't matter, so it's just here in compute next token. That's the only place where we have to make lots of changes. And here's where we dispatch. So if our token is valid, start a new token. So once we hit an invalid token, like basically it means we're at the end of the file and there's nothing more to get. We'll go ahead and start a new token because we've already in theory returned that one. While we aren't done with the current token, or if we are done, if we hit the end of the file, here's our different dispatches. Except in this case, this is it. This is where we're working. We're going to spend a little bit of time here. And this is going to split our file. So we have chunk 1. This is basically, this is a template. Everything above here is outputted, and then we emit custom code based on our configuration. Then this is all boilerplate stuff to output. This will be the next place. So this is actually going to be end of chunk 2. Dispatch DFA by goto. Which means every chunk below this we're going to have to go renumber so that we don't lose track of what we're doing. I found this to be helpful. 3, 4, and actually I want to copy that. 5, 6, 7, 8, 9, 10. Now we have 11 chunks. 1 and 2. Boom. There we go. Now the next place where we go to happens here, and then we have the DFA complete. Not sure if we really want that here. We can. So basically it's this. End of chunk 2. So chunk 2 is not very long. It's literally from this line to this line. Chunk 2 is really small. Now it is. So let's make sure chunk 2 is in properly. VB project. Chunk index. So here's chunk 1, here's chunk 2. I'm going to push everything else down to chunk 3, and that's that. Except, write DFA goto dispatcher. I don't know if I can get away with what did we do here? This is what happens. No, wait. Let's go back to our original. We have two switch dispatchers, that's correct. DFA go to dispatcher. I don't know. I may have to make other changes to this. This takes the DFA states, which if you want to know more about that, let me know, and I'm happy to discuss it in any level of detail. Emit DFA state go to. Here's the start state. If we're done, go to complete. Otherwise, the states just go to each other, really. If we accept, the accept does some slightly different things in goto, right? Emit the transitions. In a go-to condition, it's slightly different. Oops. Drop something. There it is. All right. Basically, the first time we run this, there's no chance it's going to work. So maybe we're just wasting time trying to remember what this all does. Okay. I don't know, maybe it'll work. So basically we have the lazy switch, the lazy go to, the batch switch, the batch go to. See how far we get. If we can reuse that much code, that could be amazing. I assume we'll have to make a few tweaks here and there, though. Compute next token. I'm not too surprised by that kind of thing. DFA complete. Tokenize the trailing bit. So actually, this is all inside of a while loop that doesn't need to be here, I think. And DFA complete isn't really a thing here. I don't think the while loop needs to be here at all. Let me just go in. If we're done, mark it as complete, which jumps us out of here. I think this all actually comes outside the while loop completely. State 1. And this doesn't go here. These no longer reset to state 0. Okay, so there are some differences we'll have to work through. It's a little bit hard to read because of all the pound defines and the different branches of possible code in existence. I think this happens differently. It's kind of weird. We go to something like this. Something like that. So we have, if we go to, we do all this and this. Otherwise, we enter a while loop. I think this is right. This might give us different errors. Oh, in fact it will. We need to just call this DFA complete. Why don't we flip this logic? If not defined this, do the normal thing, else. And if. Elpsy Kangaroo, how's it going? So far, I'm doing pretty good. I'm a little bit slow today. We had United States Thanksgiving yesterday, and I've eaten way too much. So just feeling a little slow, a little sluggish. Too many carbs. Mashed potatoes and turkey and gravy and rolls and stuffing and way too much pie at the end of the day. Feeling good. Feeling good. How are you doing? So if we're not dispatching on goto, not goto, there's a while loop. If we're in goto, that thing. The Master Lich, thank you for the follow. Welcome aboard. How are you doing? Same, I made macaroni, mashed potatoes, stuffing. Should have just made vegetables. Haha. Yeah, yeah. I followed because you use Emacs. Ah, I can see we have a person of great taste watching the stream. Excellent. Yeah, Emacs. Emacs is pretty good. Nice. Well, we're building a compiler from scratch. We're doing it the hard way. We're doing it all the wrong ways, just because I want to. A tokenizer itself is not hard. It's a loop through the characters. And then, depending on what character you see, you choose what to do. But we're writing a tokenizer generator to start with, and every which way I can think to implement it, we're building it all those ways. So we're dispatching we're doing this all using a Thompson's DFA construction for regex, no backtracking. I think that's going to be more efficient. And then everywhere that I can think of a different way to dispatch states or read files or iterate over strings, we have a pound define for that. So today we're building the goto dispatch in the lazy token generation branch of the build complexity we've got built up here. Now, eventually, we're going to get it all working, and then we'll build up a large body of text, and we'll try every combination and see what the actual performance measurable is. So, it gets a little complicated. If I picked one and just went with it, we'd be done already with this part, but that's not the point. This is my relaxation day. Monday through Thursday we do some game development, so I need a little palette cleanser, a little change in scenery, and that's what we're doing. Yeah. How long have you been using Emacs? Let's see here. Since around 2005. So what's that put us at? Almost 20 years? Oh gosh, I'm old. What happened? My Emacs has been pretty static lately. Like I need to go in and teach myself some more and go clean up my .emacs file. We'll probably do that between projects. We'll do like an Emacs rebuild from scratch where I go through line by line my .emacs and decide what to keep, what to get rid of. So yeah, how long have you been using Emacs, Master Lich? There's no way this works, but it might work differently. Yeah, I've got so much dead config in my .emacs. It's pretty sad these days. I've gone from Vim, NeoVim, Ed, Helix to eventually using Emacs. I just started using Emacs at the beginning of this year, and I plan on keeping it. Nice, nice. Actually, I've only known one other person that learned both Vim and Emacs, and he went the same direction you did. He started in Vim and then moved his way to Emacs. I've used like Nano and a couple other things due to system requirements in more secure locations. But yeah, Nano was close enough to Emacs; it wasn't too bad. But I knew this guy. He learned Vim. I tried to convert him. We had some friendly back and forth. It was pretty fun. But he got a job somewhere else, and there was a guy he worked with who was very abrasive, I should say. And so my friend, and he was like a huge Vim like acolyte, like a total proselyter for Vim. He was a true believer, and it annoyed my friend so much that he stopped using Vim just so that when the guy would pop onto his computer to configure something or whatever, it was all Emacs. So he forced himself to switch to Emacs out of spite. But yeah, you're the only other person I know that's been Vim and Emacs. That's pretty cool. I keep thinking I should learn some more Emacs so that when I'm on a system without Emacs, or learn more Vim, so I can just be semi-proficient in it. But I've already got all this muscle memory configured in my Emacs fingers. So strangely, that did build. And there's no way it's correct, because there are differences. So we're looking for the if not def, DFA dispatch goto. Here's the else. So this is the goto version. We ask if we're done. Otherwise, things proceed as expected. Actually, there's very little variation here. So this is a place I might consider looking. State 1 is a default accept. So this is the other. Every time we do a go to state 0, that's actually a we're done. This actually goes to maybe like token complete. Yeah, so here's the accept, go to 0. I have to think about this for a minute. Do you do test-driven development approach to this type of thing, or in general? I just ask because you talked about measuring the performance. Yeah. So the whole point of our performance switches is I have some intuitions, and I've done things before where I've tested, but is a switch statement faster than an array lookup, or is that faster than just keeping a single pointer around? Is that slower or faster than a goto? I have some intuitions, but I want to measure the actual impact. So for now, what we've got is this test permutations, where every build option we have, we build against it. So maybe what I should do is put this back in and just show. This takes about 4 minutes to run. So if we go dot slash, let's see here, test permutations.py. Pardon me. So what it does is it cleans out the project. It embeds our new code snippets from scratch. Then it rebuilds our Tokenizer Generator, builds the executable and the object files. Then it sets every one of these permutations. This is a build. Then we support 3 different encodings, so it rebuilds once for each of these, and then it runs the tests. And there are some number of tests. So test.cpp. Every time we run one of those tests for the 3 different things, it's running these tests. So does it contain an unexpected character? Do we get the right number of errors out? Does it end with an incomplete token in an unacceptable state, like an unterminated string, right? So here's bad stir with no closing quote. All sorts of different tests. So it runs each build 11 different times, it looks like. So each one of these passes means it's done 11 different strings that it's tokenized. And this one is dispatch switch with a batch process using our own iteration instead of an actual iterator wrapper around things. This one was built with macros. This one was built with functions for the helper methods, different file open methods, all that stuff. So usually I'm not super test driven, except that this project became so big and complex with all those pound defines that I kind of need this. Otherwise, I'll break something somewhere and won't know where until accidentally. This also follows the same pattern we're going to use for the actual performance measurement later. Eventually, we'll do like a million lines of text that we have to parse, tokenize, and we'll measure every one of these build combinations against that and measure what kind of performance impact each of those decisions makes. I'm not sure if I'm using that term correctly. So when I hear test-driven development, what I hear is that first you think of all the conditions and you write a test for each one, and then you write your code to make the tests pass. So it's not far off what we're doing. Is my code on GitHub? No. I don't believe in feeding the AI training that they're trying to train to replace me. Oh, nice. I'm supporting UTF-8 ASCII. What is Latin 1? Oh, yes. Let's talk about that. We do all of those. So, let's see. Where's the best place to go to? Maybe in assets, character reference. Oh, code. Character reference for ASCII. Okay, so here's ASCII. I'll put it in the thing. ASCII is a 7-bit standard. It's actually kind of an interesting standard. It's not the only one out there, but it did win. There's another one. Let's see if I can go dig that up. EBCDIC. EBCDIC? How do I spell that? There we go. So this was an early competitor to ASCII, interestingly enough, but it's basically ASCII was for a 7-bit terminal to transmit data over a phone line. So you'd put your phone in these 2 rubber cups, and the rubber cups would, one was the listen, one was the emit pulses, right? And there would be another terminal on the other end, and you would type a letter and it would punch holes. Well, it would send the signal by pulses over the line, and on the other end, the receiver would punch a row of 7 holes into a paper tape. And that would represent a character, right? So it was called a terminal. So ASCII is a 7-bit standard. Later on, IBM came up with the extended ASCII, and then everybody else had their own code page for the other missing bit for 8-bit words, right? But ASCII is a 7-bit standard. So in our case, it will check and make sure that every single character is valid ASCII as we go. Now, Latin 1 is a supplement to that that's, I think, become more standard than other options. It basically gives you the full 8 bits. So every character, I don't have to check if it's a valid byte or not, because it always is in Latin 1. That gets you a few things like upside down question marks and upside down exclamation marks and characters with accents and things like that. So it's an 8-bit standard. Then, yeah, we support UTF-8, which is a variable width Unicode encoding, which I mean, I can share a link to that as well, although most people, I believe, these days are fairly familiar with the UTF-8 standards. But we check every character to make sure it's valid as well. So, and we do some fun things with it. So, for example, let's see, is our test still running, I assume? Oops. Oh, we did. We finished. So, yeah, 132 tests. In other words, 44 times 3 times 11. So, we're running a lot of different string parsing to make sure that all the build options are there. So one thing we can do, and the last build was ASCII, unfortunate. Let me recompile this one, not that one, file. Let me compile this. So this is my standard compile, and I think oh, come on. Compile. Test ASCII. There we go. Compile. Yeah, we'll just run this one. Test. So we'll generate a quick one real quick. Ooh, always just assumed ASCII and UTF-8 were it. I didn't know ASCII only uses 7 bits. Yep. So I would say probably most people are going to go with ASCII, although if you wanted that little bit of extra speed of each character, we don't have to check if it's a valid byte. I prefer makefile over CMake. Yeah, I like to be closer to the metal. CMake, I think, it's a layer of abstraction I don't need. And if I don't need it, I don't put it in. So let me show you one thing we can do with ASCII, or with UTF-8. So MDSP. In my last company, we had these YAML files. We use we used YAML files for configuration of things, and people kept breaking the system. They'd come to me and say, hey, it's broken. I'd say, show me your config file. And I'd open it up, and I would find non-breaking spaces, which means they were copying and pasting code off of the internet, or configuration off the internet, and getting non-breaking spaces. So now, what I did is, since I support UTF-8, this test.vvvtoke, when I say \s, if you're in UTF-8 mode, we check for non-breaking spaces. Our regular expressions also handle these kinds of characters. So we can do a character range for the Cyrillic alphabet if you want to do Russian or Mongolian or something. And we also, here's the Greek alphabet, everything from alpha to lowercase, capital alpha to lowercase omega, and it works. So if I go in here to, well, I'd probably just copy the character. That's probably the easiest way to get there. So there you go. D090 is the A from Cyrillic, and here's the D18F for the Ya, and here's the alpha and the lowercase omega, CE91. So this A and this A are not ASCII A, and they are not each other, even if they look the same. So there you go. We do all that out of the box for us. It's a gimme. We can do some cool things when you actually support UTF-8 inside your regex engine, which I've never seen anybody else do very well. Oh yeah, I use YAML for my serialization, deserialization of my engine. I was thinking about switching to XML or JSON or whatever. I get what you mean, yeah. YAML has some weird things in it. Like, I remember there was this whole thing around using Y as a key in one of your values, key value pairs. Like you can't, it has to be quoted, but none of the other keys do. But people would always forget. So it'd be like, Y is, and then your truthy values are all redefined, and some weird choices in YAML. If I have to choose, I usually go with like a JSON. What? That's where it's, yeah. So if you had like X is 15 or 12, and Y is something else, maybe it's 60, 59 or something. You can't do that. It redefines Y, which is the truth value for yes, no, Y, no. It redefines it as 69 instead of true or false. So you have to enclose Y, even though X, Y, and Z didn't need to be quoted. Just the Y does. It's bizarre. Yep. Yeah, YAML has some issues. JSON is better. There are things I would prefer to change about JSON as well, but at least it's not XML. Bruh. In fact, I'm kind of thinking what we're going to do for our performance test is a JSON tokenizer. Because I can find large sample files of JSON without any trouble in the world. I can generate large files of JSON without any trouble as well. But yep, fun times. So like I said, I'm just trying to mess around, have fun, and do things I haven't seen before. We're getting close to the point where we're going to start doing some fun things. We're going to do a bit mind-bending tricks here shortly. There's an error case that we haven't run into yet with my testing, which I know is going to come up, and that's going to open up another branch of pound defines for us in here. I already know we're going to run into it. Not here. Yeah, and sure. I mean, in our list of these things, it'll be priority disambiguation, for which DFA state gets dispatched first. Yes, it's going to be great. I'm going to head out, do my stream, hop back on if I'm still on. Yep, I'll be on for another 4 or 5 hours probably. You have fun on your stream. Good luck. Yeah, so I know I'm going to add at least one more pair of options here for state prioritization. And then we're going to rewrite where we read in those config files, we're going to start using our tokenizer to feed us. So we're going to write code that reads a config that writes out code that is going to read in our config. It's going to be great. It gets very meta after a while. Once you do that, changing your format for your input file, your config file, gets easier, but you do have to go through that stage first. Right now it's pretty hacked in. Then we get into some weird ideas. Nice. Yep, catch you later. Okay. So, where were we? We're looking at this, and basically we have this one, which says we're done. And then we have, this is all state one. State one is always the biggest one, because you're checking for the most things. And then we have this one. And then we have this one. So there's basically three things we need to do. Else. So a lot of these actually go to DFA complete, except then we're just going to call it token complete because it's not the same thing as DFA complete. Oh, this is going to state 0, DFA complete. I think it's more readable if we do it that way. So we have to know if we're lazy or not, but this one is lazy. So we can project. So where we write out this DFA switch dispatcher, we just need to know if it's lazy or not. So this one will be lazy, this one will be not lazy. And we're not gonna get any fancier than that. PP project, HPP. Okay. Go to dispatcher. Bool is lazy. That's it. Bool is lazy. Which means we need to pass it. Oops, not that one. Off by one error. Here we go. Bool is lazy. Emit DFA state is lazy. So we need that one as well. Instead of going to DFA complete, we're going to call it token complete. But it's not the end of the full DFA, just the end of the token. So that's one thing. Emit transitions. Oh dear. This is going to start being a little bit ugly. If it can accept, it goes to sometimes token complete. Otherwise, it goes to DFA state whatever. If we accept. Okay. And then emit transitions. This function is going to start getting even uglier. Emit transitions. Is it goto? Oh, and if it's goto and lazy, we can make a change. Yeah, I think we need to just keep this going. Is lazy equals false. That'll be the default behavior. I always hear this is really bad code, but I'm not sure that in our case passing two booleans is all that bad. It's not the most readable, but what we're writing out is already pretty unreadable, so it doesn't matter. We're just playing around. Later, when we decide the full set of build parameters that we prefer, we can delete all the other pounded defines. It simplifies everything a ton. But we want to test all of it, so it's okay if we go through some yuckiness now. Now what happens here is blah 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 blah. If this is a goto, if is lazy, we do one thing. Otherwise we do something else. It now looks the same. But instead of going, I think we just go to token complete. I think that's it. Else accept. So here's another place for laziness. If is lazy, we do, where's the go to token complete. Else, if it's go to token complete, otherwise DFA complete. All right, let's see how that goes. Probably made some errors, made some mistakes. Actually, I can already think of one. DFA complete, token complete. So yeah, we're just having fun. This is probably the last major piece of all the different build options. Read from disk. Thought else if is done. I should be going to somewhere else. The project DFA complete. DFA complete. Those should be token completes if we're lazy. Oh, ha ha ha. Okay, I know what's going on here. Go to dispatcher, go to dispatcher. So this one needs to pass on to this is lazy, and then this thing we forgot to pass this one is lazy. All right. Cool. Okay. Maybe we missed a thing then. this one. This is not one we need to do. Or this one. Nope, this one we need. This is an accept. Start state ID. If it's done, go to complete. What was this one? This is an error. Actually, in the case of an error, we start a new token and go back to the top. I think maybe that'll make more sense. Yeah, this is needlessly complex, but I want to measure things. Oh, cool. What are the odds source builds debug VV test parser? Oh, did that just work? So we're built using UTF-8. This is a manual test run, not an automated test run. Dispatching with goto, lazy processing. This doesn't matter. That mostly doesn't matter. Helper functions. File IO fopen. Here's our text. So YouTube, hello, omega x, slon world, things and stuff, string with escaped quotes inside, period, pleb, and an unterminated string token. Okay, well, it didn't work, but it didn't crash. So shockingly, that's not the worst outcome we've ever had. I've had worse. Huh. That adds 1,000 lines of code to our file, pretty much. Yikes. Okay. Like I said, there's at least
Hey, Dad. Gotos.
what? Oh, just a moment. Let me see what my son needs. Okay. Poor son. He needs someone to play with. Right now, nobody is playing with him, it sounds like. Okay. So it's stopping after getting the first token, not processing any further. So lazy. Oh. I think I know what's going on. Blah, blah, blah. We'll come back around that. In an accept as a function. Start a new token. If it's a goto and we accept, start new token. I think I know what's going on. Okay. Accept. Go to complete. But the problem is accept doesn't tell us whether it's kept or not. So when we come here, we have to make a choice. Okay, okay. And here we have to make a choice. Okay. So we have to ask, is the token valid or not before either of these? All right, we're close. We're close. This is actually shockingly close. Token complete. If it's lazy, we need to be a little bit more complex here. Oh, this is actually fine. This one does need to be done. Okay, if we can accept, we do an accept. If it's lazy, this one we need to do. Here's token complete. This is one we need to do. Not this one. Oh no, this has the accept, so this also needs this. Blah blah blah. We actually can simplify this a bit. This is not an. This is fine. Okay. So we have our two bookmarked XYZs. Is valid. Oh, awkward. Is valid as token. This is what we're looking for. If token is valid, then we do that. Pop. Else. That's it. So if we accept, we say, and if we're lazy. If we're not lazy, we don't have to worry about it. We just do this. If the token is valid, then we're done. Otherwise, we do that, which means we can simplify our code somewhat. I don't know if it's any simpler. basically this. Let's mark these two again. Do I want to simplify this at all? If we're lazy, then we pop one more time. I don't know if that's easier to read or not. All right. If it's lazy, yeah. All right, let's see how that goes. Let's build that. And if that works, we might just be very close to done. Oh, unterminated token at the end of text buffer cannot be accepted. That's perfect. Because bad stir. Yeah. Yitsu hello. Omega on line 3. Comma X, line 4 slun, which is elephant. Yitsu's eggs. Egg. World. Exclamation mark. Things and stuff as a single string. Dot. Lieb. And then a failed. It's working. Oh my gosh. That took us less than 2 hours. That took us less than an hour and a half. Even in a carb funk day after Thanksgiving. Amazing. I'm getting lucky today. All right. Do we just run the test then? That's permutations, not. Uh-oh. First, I have to put that continue out of here. In theory, this just works. So we're gonna get more than 134, more than 44 test cases, because now we'll do the goto and lazy. Fail. Okay, so something's failing. We'll have to look at the logs. And then the other question is, did we break anything else? So we do kind of need to let this run. But it looks like goto and lazy are broken. I guess I'm not too surprised, but it'd be nice if it had succeeded a few more. So goto with batch is still working. Basically, the more important, more impactful defines are out first. So goto and lazy is failing. We can look at the log while we're waiting for that to complete. Right, I'm saying 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 failures. Result. Oh, not that one. Let's see here. Here we go. Could not find file. Interesting. Oh. Pass. Missing file, cannot find the thing. Pass. That's expected. Empty string. Pass. White space only did not work. White space and comment only did not work. Okay. I have an idea where things are going here. Ends with a discarded token. So the line count numbers aren't keeping. End with a kept token. End with an incomplete token. Passes. Unexpected character. Expected 3 lines got 2. Okay. So lines aren't working. It's mostly just line counting. Wow. That's 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 not bad. Yeah, it's almost all differences in line counting. It's failing the last line count for lazy. That shouldn't be too hard to find. Everything else is a pass except for the first 12 tests, right? Pass, pass, pass. Yeah. Yeah, so let's let it go through the full run just to be sure. Then it's lazy go to line counting. That's the only issue. Not bad. Not bad at all. Doesn't look like we broke anything else over in there. I thought we would spend a lot more time on that. We should go back to the log file. So that's the 2. Here's the other one again. Just line counting mismatches. I'm kind of looking for. Well, this one failed. Read from file. So this one broke, but mostly again. Okay, so UTF-8, go to lazy generator. There are some other issues, but we need a lot of these tests working if we just fix the line numbering issue. Yeah. This one looks the worst. Possibly due to the macros. Let's not get ahead of ourselves though. Line counting seems to be the first issue. Then macros, I think. Yeah, these are functions. Functions, yeah. So macros. When a macro accepts, that's probably our problem in lazy. Not bad. I think it's 48 full tests now. 48 times 3. $32 from 144. That is indeed a difference of 12. So line counting. It's not counting that last line. So we go here into log. It's always one short. Which leads me to this. If we're done, if we're at the end of a file, it's not getting into here. The token start character is valid. So let me go back to the old shell where we ran 1, 2, 3, 4, 5, 6, 7 lines, and that was correct. Hmm. Hmm. Is it because we double accepted something? Or failed to come in here? When we accept with gotos, I don't think we start it until later. So if we come into begin, does it have a token? Give me the next token. Compute the next token. So it comes into our goto and goes until it has a successful or until it bails out. Go to token complete. If we are done, accept new line. If the token we're currently looking at is not past the end of the buffer, is basically what this is asking. What if we turn on tracing? Then we run one of our other test strings. Test. So instead of taking this one, what if we took that one? Okay, this says 6. 1, 2, 3, 4, 5, 6, 7. Okay, now let's trace log the tokenizer run. So that's going to print a lot more stuff to the console. Oh. I'll be able to see what's going on, maybe. Blah, blah, blah. Comment, white space to the end. Accept. Start new token as part of the accept. Let's just try something here. What if we just always take the tokenizer to computer new line? Always. In this case. Seven lines. Let's run it with this one. Ugh. 1, 2, 3, 4, 5, 6, 7. Now that's reporting 8. Okay. If the last token was something we wouldn't keep, so these three. Or if it's empty. Lazy processing, throwing me for a loop. So this is for not lazy. And this works for some of the cases, but not all the cases. We want and name underscore token dot is valid to be not. I don't believe that is correct. I think that'll break for some of our use cases. So that is 7. Oh. This one has 6. That's a lie, I believe. Oh, I can't read things with this here. I think all of them are designed to be 7 lines long. One, 2, 3, 4, 5, 6. There's a 7. So that fails. I think there's one other test we need to run here. Confetti. Let's do this one. So basically we end on a token week key. This would be 6. 1, 2, 3, 4, 5, 6, 7. Oh, 1, 2, 3, 6, 7. So this should be 7. So this should be 8, right? Oh, I didn't build that. File. Seven. So this should be 8, right? 1, 2, 3, 4, 5, 6, 7, 8. Six. 1, 2, 3, 4, 5, 6, 7. So that's one short. Hmm. 1, 2, 3, 4, 5, 6, 7. So all of these are short by 1. Exactly. Basically all the ways that a file can end. I just have to make sure I test for the right cases. 1, 2, 3, 4, 5, 6, 7 is correct. Interesting. So this one works. 1, 2, 3, 4, 5, 6, 7. 7 lines. This one works. Okay. If we're off the end of the buffer, new line. Oh, if it's an empty, so maybe I was right. Let's go back to this one then. Either way, we new line. Oh, we can't quite do that, can we? Is this it? Six lines. 1, 2, 3, 4, 5, 6, 7. So this should be 7. So this is now wrong. our way back up the list. Oh. Always a little subtlety around the different processing methods and the end of your text buffer. 6 lines. Yep, wrong. Let's see if we can figure out what the pattern is. 1, 2, 3, 4, 5, 6, 7. So that's correct. One, 2, 3, 4, 5, 6, 7. So that's correct. If we end in a new line. Oh, cheap viewers. I don't want cheap viewers. I want expensive viewers. I want rich viewers. 8 lines. 1, 2, 3, 4, 5, 6, 7, 8. Even if it's a blank line, it still counts. And if we end on a token we keep, one, 2, 3, 4, 5, 6, 7, correct. Which means the only one now that's broken, this one. Six. 1, 2, 3, 4, 5, 6, 7. Okay, so let's figure out why this one case is different. Oh. We're back to this. What we're back down to. Seven. Seven. 1, 2, 3, 4, 5, 6, 7. Also 7. Did it just come full circle? If I actually count the number of lines in the file, I get the right matchup. Maybe I abandoned this line of code 1, 2, 3, 4, 5, 6, 7 because I assumed I was consistent, which I am not in this case. So this one should be 8. Does that mean everything else is 7? So maybe for my own sanity, I could engineer this like this. So there are just always 7 lines of text in our example. That's all right. 8. 1, 2, 3, 4, 5, 6, 7. So this does not have 8 lines. This is so close. Actually, I think it might just be this. If we're not off the end of the buffer, do that. Instead of an else if, it has to be an actual if. 6 lines. That's not right. 1, 2, 3, 4, 5, 6, 7. Oh, and we flip it. Nope. Not equal to 0. Wait. This results in exactly one case where we don't want the new line. And we get it anyway. So I have to figure out what that one case is and how it's different from the others. So this says 8 now. 1, 2, 3, 4, 5, 6, 7, and it's this one. We test all the other ones. So what's different about this one at the end? It gives us the extra line that we don't want. What is the condition around this one that is different? Why is this getting 2 new lines? We're so close, but what am I missing? So if we end in a new line and nothing else, that does need the new line added. If we discard the tokens after the new line. So what's different about this one is we kept a token on line 7 and we don't need to mark line 7 otherwise. Except that's a 7. Because what I'm thinking is, if we have a character here at the start, so if we haven't basically moved our current character we're starting a token from, off the end of the buffer, we accept. If this token is not valid, then it was something we either discarded or didn't complete, in which case we need a new line. But if we did complete it, if it is valid, we don't need this new line character. That's what I'm currently thinking. So that fixes this one. A little text file that ends in new line. Seven. 1, 2, 3, 4, 5, 6, and a 7th blank line. Correct. I think this does it. 7. 1, 2, 3, 4, 5, 6, and white space. 7. Like I said, each of these processing methods, you kind of have to think about the end slightly differently. So 1, 2, 3, 4, 5, 6, 7, which is a comment. And then an incomplete token. So this should fix everything except macros, I think. One, 2, 3, 4, 5, 6, 7. Arguably correct. So let's run this one. Time. Okay, so it's going to recompile VV, clean, and some of these will pass until we get to helper macros. This should fail. Okay, so we're down to just the macro bug. Oh yes, helper functions are fine. So it's the macros that we need to fix. And everything else should work just fine. Okay, because we've already got tests for those. Okay, cool. Almost there. Journal. I did not start today's journal very well. Thanks. 23. No, not 23. What am I saying? 11:29. Good heavens. How did we almost get done with this year? Notes. Tasks. UFA state dispatch, go to label for lazy processing mode. Notes. This is probably a good place to save it. Implemented. Go to label UFA state dispatching in lazy processing mode. There are a few differences between batch and lazy, but passing some Boolean flags seems to have fixed it. Project seems to have fixed it. There was one other piece around the end of file and line count mismatching, but that has also been fixed. Next up, let's see here. Implement gotos in lazy compute next token. So that's done. Fix end of file line count mismatches. That's done. Lastly, Fix macros. That'll be done next. We should save our work here. Oh, let's see here. -m lazy processing now has go to label dispatch. Some issue remains with respect to macros. And I'm thinking I know what that, or what kind of thing that would be. It has to do with what's happening inside of accept. So there we go. Get status to do journal. Okay, so let's go fix our macros, which has everything to do with this. Let's go to makefile. Make sure we build this way. And I think the issue is basically when we say go to inside here, we don't go here. So this is if we're doing function pointers, if we're doing this in gotos, if we accept go to token complete, I think that's the issue. If that's it, then we may just be done with this at 2 hours. It'd be pretty good. Run a clean and test. Yeah, that was too fast. It feels like this is a long time coming because we only do this once a week. It really does slow down your progress. Oh. What am I doing? Let's just do this one. 1, 2, 3, 4, 5, 6, 7. That's the correct number of lines. Begin and no tokens. Okay, well that's not right. If we accept, we do the accept actions, we start a new token, and then we go to oh, that's in batch. We don't want batch. Okay, there's too many accept functions here, or macros. Macros do have a weakness in that you can't define a macro within a macro, so I have to have different accepts. So batch. We need the except. That's for lazy. Helper macros. Processing batch. All the way down to here. Then if process lazy except. And here's our go-to. And here's the one we wanted to actually fix. This one. Go-to. Token complete. Ugh. Like I said, there's just too many options. I know of one other place where we're going to have two options, but it's actually going to be at the build time at the higher level. No. Still wrong. Accept. Let's see here. Let's reorder these. Go to iterator macros. Something like this. Okay. Go to lazy macros. I don't know. What are we doing wrong here? I feel like that should have done it. New line was not declared. Get line? No. So somewhere there's a new line that's wrong. Yeah, basically we have to use a variable here because you can't have pound defines or ifs. You can't have pound if defs inside pound defines. So when we use macro logging, we have to use this way. Helper macros process lazy. Go to lazy accept. Very strange. Let's see. Rule 0, new line. Because lazy. Here, this one is inside. Batch. Let's see. Let's put this in between. Helper macros. After lazy. After batch. When we put this above where we check for batch. I don't think new line is actually different between the two. Oh. Oops. That happens in Tokenizer. Pound define new line. We put this here. Maybe that fixes it. Okay. What? No, I did not mean get line. Guarantee you in function. Oh. It's in the function. Do accept actions. Why would do accept actions? This is now an enum class, I think. That to do goes away. These are property scoped now. New line. Do accept cases. New line. Helper macros, new line. Undef new line is down here. That's like at the very bottom. Okay. My eyes are a little irritated, not sure why. Ugh. How can it say that except the new line is not defined? If macros, new line is easy. Line number, character in line, none of that matters. Define the line. Line start cur character equals current. Oh, I messed up. I made file? Yes, I did. I reordered. There we go. That's my bad. Zero 7 so 13 1 accept end. What? Huh. Okay. Here's a possibility. Lazy accept. Go to lazy. We may not be able to do this here. No, this feels right. That's like this is. Do accept actions is just too complex to want to put it inside of a macro. Hmm. If I state 13, 13 consumed the O. Now we're looking at a new line. When we go to 13, it says, oh, new line is not us. So we go to state 1 where we accept. Keep the token, although it never generated the token. I know it thinks it's done. Start new token. Huh. Oh, go to and lazy. So this function. Okay. Okay. I think. This is where our issue mostly stems from, X, Y, and Z. If we go to accept, there is no go to dispatch here, which is why in VB project, when we accept, what happens? go to. This one here. Emit transitions. So in the case of lazy, goto is handled here. So we're shorting that. If we do it here, fine, except I think this. I think that, but I could be wrong. Whoa. Okay. Let's run that again. Maybe we did need that one in there to balance the pushes and the pops. Okay, blah 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 blah. Yeah, things are not great here. Go to lazy macros. Itsu. Accept. Pretty much our new line. Accept the new line and run the new line function. DFA state 2. DFA state 1 is not actually going where it should, which is why this indent keeps going. Accept new line, and then it does a fall through to 2. DFA state 2. Yeah, that just ends up in a weird state. So DFA state 1. Okay. So this should be lazy. This is the begin. compute next token. If it's not goto, it is goto. Go to 0. Blah blah blah. It was getting a character, and I don't remember what it was. Oh, one of the okay, so it goes here to one of these. Munch. Go to 10. It's gonna hang up in 10. Complete. If it's valid. Accept. And accept. Munch. State 7, 13, 13. Is this out of date? State 0 goes to state 7, where it consumes. Oh, I see. This has to do with the fact that we're running this thing. Let's take that away. Because that does confuse things a bit. Hmm. 0, 9. Accept. Then go to 0. Punching up white space, accept, new line. Accept new line, and then it never goes to 2. We want is DFA state 1. Accept. Oh, this doesn't go here anymore. Or if it does, okay. I see. Start state label. I'm pretty sure is the one we want. Okay. Think that it's just so hard to keep track of which how defines are active at any given moment. Huh. Well, one would argue that's worse. 9 accept 0 munch accept new line. Go to and lazy. Hmm. I feel like that coding change didn't come in. Pat, hello, what do you think about AI? Can AI write a whole project on itself? Depends on the project. Myself, I'm not interested in AI. I don't particularly use it, don't particularly want to. I think the fun in coding is in the art itself, not necessarily in, well, let me think. You can buy IKEA furniture, or you could pay somebody to make a crafted custom set of cabinets for you, right? Now, maybe you want the cheap cabinet, that's fine. But if you make it, but there was something lost in that. If I can say that there's something lost in the commoditization and the cheapening of creativity. So back in the day, the only way to get your cabinet was handmade, and everyone was different. And for an apprentice to learn the craft of making cabinets, there were ways that they could get paid while they went from a crappy woodworker to a master woodworker. However, when you go to something like IKEA, there's tons and tons of crappy stuff available cheap, which reduced the need for the number of people who were only okay. So how many people now go from the process of being a crappy woodworker to a master woodworker is very, very small. And there's almost no way to get paid while you do that. I think AI is going to do the same thing to art and coding. How do you go from being a crappy artist to a great artist and get paid while you do so? Well, you can't, which means that the only people who can afford now to go from crappy artist to great artist, or crappy programmer to great programmer, are the ones who don't care about earning any money at all for the 10 years it takes to learn how to be good at it, or whatever number of years it takes you. It's basically making it harder to go through that path, because nobody wants, if they want crappy or mediocre, they can just have an AI do it for cheap instead of paying in order to invest in somebody's future capabilities, which has been a long time commoditization of programming anyways. They've slowly been turning programmers into cogs in a machine that you can replace and swap out infinitely, which means there's no longer investment in that training, and AI is just going to make that worse. Can it do things, a whole project? Sure, with enough human guidance. Is it going to be good? Probably not. Is it going to be as good as a mediocre or crappy programmer? Sure. But it'll never be as good as a good programmer using current large language learning model techniques. Because the large language learning model only learns, it is only imitative. It cannot be creative. Yeah, so I don't know if that helps much. Also, welcome to the chat, Mr. Looking 42. 42 is a great number. It is the answer. Oh, what do you think of AI? What are your thoughts? Not saying it's not crazy at what it has become in the last few years. It's made huge strides, but I think the strides are not where people think they are. And I'm not sure that it's a good idea. Technologically impressive does not necessarily mean good. What is a technical assessment? What is a moral assessment? But if you are creative, then you can make AI creative also, right? So far, no. Because here's the problem. Right now, AI is most of the advances in AI so far have been in the large language models, right? And what those do is those ingest a lot of material, and then given a prompt, it says, given these words, what have you seen around those words that you can imitate? Predict what a human might have done here, right? Well, that then just looks at its body of work and says, oh, when I see these words, here's what I output, roughly. We estimate that most of the time this is what a human would output in these circumstances, which is not creative, it is strictly imitative. And I have some very real-world examples of that I know a modern AI could not arrive at without an awful lot of human input guiding it to the solution. Another thing that AI is not very good at is evaluating its own outputs. There are lots of examples of AI outputting something that it thinks is reasonable that a human would look at and say, no, why are you even answering that? What is that? Well, like Google AI saying to put glue to keep the cheese from sliding off your pizza, or generating images of black Nazis or Oriental Vikings, right? If you asked a human artist to draw Viking, there's no way it would even come close to doing that. There's no way for it to evaluate, is what I'm doing absurd? It can't ask that question. It doesn't know what absurd means. It doesn't have context. It has, I think this might be what the next word needs to be, or the next pixel. So it's strictly imitative. That's all it is. Which, again, the capabilities for imitation are unbelievably good. If you train your art model on one artist, it will imitate that artist quite well. But it won't ever create something it hasn't seen before. Does that make sense? I hope that sort of distinguishes a little bit. Now, I'm not saying that AI in general can't eventually become creative, but not using large language learning models. What I think large language learning models have solved, is the human-machine interface. You can now type in something in English, or whatever, and get an almost reasonable response. But that's not the creative part that we're really interested in. The adaptive part. The only way to adapt a large language learning model is to add more data. Whereas a creative thing takes data that already exists and infers, extrapolates, and combines it in unique, interesting ways to arrive at more information than it had to begin with. And a large language learning model, by its definition, by the way it's built, is strictly imitative. So I don't think it can get there. Now, I think LLMs are going to be at the interface between humans and whatever the next AI thing will be. But the LLMs themselves will not be creative. It's not in their nature. It's not in their construction. Again, small projects, yeah, maybe. With enough human guidance, slightly larger, sure. But everybody I've talked to, if you use it too much, it ends up causing more problems that are harder to find than if you wrote it yourself. You end up spending as much time evaluating the AI's output and trying to debug that as you would have if you just written it from scratch yourself. Minus the fact that you don't understand what it output, right? You didn't write it. There's a difference in humans. When you create something yourself, there is a connection to it and an understanding that takes hours and hours of looking at someone else's creation to understand the subtleties of it. So yeah, I don't know. What are your thoughts on AI? What do you want AI to accomplish? I guess that's a question. Here, let me give you a quote. Jerry Seinfeld, I forget which college, maybe it was Duke University. Anyway, commencement speech. He said, it's amazing that humans are smart enough to be able to invent artificial intelligence, lazy enough that we need it, and we're too stupid to understand whether it was a good idea in the first place. I think that kind of sums up very nicely how I think about it. That's amazing. It's cool. It's crazy what it does. But like, if I want to learn to draw, I'm going to go learn to draw. I'm not going to ask a computer to draw for me. I want to do the creative process. Art should be a human endeavor. And was it a good idea to even invent it? I don't know. That's too early to tell yet. I personally think you can't stop the invention of such things, but we should have the wisdom to be able to say what it's for. Why are we doing this? What is it here to do? And did it do it? Has AI made our lives measurably better? No, I would argue not in a lot of ways. When I look at the internet and I Google for something, I get so much AI crap now that is not good results, whether it's art or help on text. That the internet is largely not even human anymore. Except, so confused by this. Pop. Is it valid? Then we're done. Otherwise, we go somewhere else. So here's another question. what is the response curve of your AI learning models with respect to the size of the input to the training set? I think a lot of investment has been made into LLMs based on the assumption, and frankly, the marketing leading to people to believe that if you add more data, the accuracy and the impressiveness of the LLM's outputs is exponential. Do you ask it of me? Yes, I ask of you. What do you think of AI? I'll ramble and rant while you think about it. So if you double the amount of input, your quality quadruples. Double it again, you quadruples again, right? That's what people, I think, feel like. If we just put more data in, if we just add a few hundred more parameters, our model will attain sentience. What I think has actually happened is it's a logarithmic curve, not an exponential curve. So you double the amount of data you can put in. Great, it improved a lot. Double it again. Oh, it improved. Double it again. I think it's leveling off. I think the quality of AI is leveling off quite drastically. Now, for the next doubling, now that they've completely scraped all of the internet, and they have, where are they going to get the next order of magnitude of data to further improve it? They're starting up new nuclear reactors just to run AI training models. How much energy are they putting into that could be put into improving human lives and generating more human creatives? Is that energy being spent in the right place for what I think probably is a leveling off of the quality? I think we've probably passed the hump, the inflection point where that improvement's going to slow down drastically using LLMs. I think there are a lot of investment people who over the next 5 or 10 years are going to be very, very sad at how many billions of dollars they spent for a product that isn't monetizable. I think it can be very illegal if I'm creative. Yeah, there's whole legal considerations as well. Can't ignore those. If I'm creative, I can create a tool which is very illegal. That's by the help of AI, so it can be very illegal not only for this, but for everything. Yeah. Yeah. There are legality issues as well that are being fought in the courts right now. It's also being fought very creatively. There's some rather funny things happening. For example, artists, if you produce a picture, right, say you're an artist, you can take your picture and you can put it into a program, and I forget what it's called, but they call it poisoning the well. And basically what it does is it goes through and it adds little tiny artifacts to the picture that the human eye can't detect, but that absolutely screw the AI. And if you get enough of those pictures into the training data set for an AI, the AI basically cannot generate a good image anymore. It is unbelievable how much it distorts the outputs for an AI for something the human eye can't see. So, I mean, that's another creative way people are messing with the AIs. Yeah, legality, morality, there's a lot of questions open about AI. And like I said, on a technical level, I think there are some open questions that people are not addressing. So I don't know. Does that help answer your question? Or am I talking in the neighborhood of your question? Sometimes I don't always get the understanding of the question 100%, and I answer something slightly adjacent, but it is an interesting topic, AI. But one that I'm not going to spend time on. I like working on projects that interest me. So I build a game with no game engine, building a compiler from scratch, no dependencies at all. We're going to explore so many different ideas. And as we do, we will improve ourselves and our capabilities. Instead of use the cheap, easy shortcut. Why do the greatest runners in the world come out of Kenya and out of, parts of Mexico, the Tarahumara? Because they didn't make trade-offs in transportation, or they haven't yet. Most of us would agree that it's more effective to get in a car and drive to your workplace and drive back. But if that's not an option, how do you get places? You run. If you run all day, every day, everywhere, up and down mountains to get to school and back, you become a very good runner as a child. And then as an adult, even more so, because your overall physical potential increases, right? So the greatest runners in the world tend to come out of places where there's no good transportation and you just can run. The people in the Tarahumara are like, I'm going to go visit grandma. It's a 30-mile run over to the village, to her village. I'll be back this afternoon, right? Run 30 miles, go say hi to grandma, come back. That's just their day. We made a trade-off. And for us, that's a trade-off we're willing to make. I don't want to run 60 miles to go see grandma. But there's a skill there that was lost as well. Mankind, in the beginning, were endurance hunters. There is no animal on Earth, except I have one example of an exception. There's no animal on Earth that a human cannot outrun. A human can run almost any animal to death. And the whys and wherefores don't really matter, but we traded that. We traded that for cars. I think the same thing is going to happen with AI. I want a quick, dirty thumbnail. I want a fast logo. I want to create a piece of code that does this. But instead of learning the craft and doing it yourself every step of the way, so that you are intimately aware of the entire process and project and scope and what works and what doesn't, you've outsourced it to create something. But you didn't gain the skills in that creation. So when you want to make the next thing, the better thing, how do you know which skills worked and which ones didn't? What skills did you gain in that creation? What did you lose? Oh. Start new token. No. That doesn't make sense. Do accept actions is one of the few functions we actually keep between the different things. So yeah. Let me know if you disagree or have other points you want to talk about, but that is an interesting topic of discussion for sure. Unfortunately, you get a somewhat disorganized response, but I think it's the right answer. If a little discombobulated in its presentation. Like I said, nothing prepared, just off the cuff. And I'm not really a speaker type, so I'm sure it could be presented better. Blah, blah, blah. Accept. Keep this token. Here's the rule and the ID. That's fine. TFA state 0. Why did it go to 0 in this case? Keep by rule just copy the whole thing. It's hard coded. It's on the variable. Good. All right, we're in rule 7. Keep the token this way. Does the things. If it's lazy, it does those things. Rule 7. Oh. Oh. I think I know what's going on then. We can't do this here. This has to happen in the other piece. Which I think it already is. So here's the question then, and I think that my assessment is right, that an LLM effectiveness is going to level off, and I think that they will be the interface between creative AI. By creative, I mean non-imitative AI. Stop. Then what is that? What is the key? What is the difference between imitative and creative? I would argue that a lot of human activity is also imitative. An awful lot, especially when you're starting out. If you start art, you start by copying the greats, right? And you develop your own style over time. Same thing with coding. Maybe you look at somebody else's code listing and you sort of imitate for a while until your brain starts making the connections and finding the patterns and connecting them in different ways. So what is the next AI thing that will become creative? I don't think LLMs are it. LLMs are really just a special case of technologies from the 50s and 60s anyways. All of AI right now is not a new idea, just more processing power, more data. So it's the same tools from the 50s and 60s, just scaled. So what's the next idea? Actual idea. What's new? I don't know. Rule ID 7.5. Set up our token. If it's lazy, ID buffer is valid. Okay, so this comes out of this is the this one, this one, this one. So we went into Russian mode, so that's rule state 7, which goes to 9. We come into 9. Until we accept it. Token is valid, then we go to token complete. Here. If we're done, we do the thing, blah, blah, blah. But we are not done. Which does remind me. To do this. Blah, blah, blah. I've had some various thoughts on the AI thing. We may do like a mini lecture one of these days. It's a little more prepared and outlined. Compute the next token. Is it valid? Return the token. Start new token. So come to state 9. Hangs out until it's done. Very strange. Very strange. Go to and lazy. Do the accept options. It's just macros. What am I doing wrong with my macro? Hmm. So using macros, this doesn't even matter because it's jumped over. That's fine, lazy. The dispatch methods are fine. Pointer lambda is fine. Goto. This is literally the only problem I have. Hmm. Huh. Confused. Genuinely confused. Oh, and I'm out of hot water. What is it about this macro? Where's the other one? I think in this case, if it's a macro, it's this thing. Um, if it is helper macro, these kind of need to be here. I think. Hmm. Ugh. Keep this token. Oh, so it actually makes it through. Oh, come on. HELLO. So it's getting through more stuff. It's not marking things correctly. But we hit this last one. accept. And then it never bails out. It's also not indenting the tab correctly, but that's okay. Go back to functions. This all works fine, right? I don't think I broke it there. Well, it may be time for my water break. I'm gonna heat up some more water, I think. Okay, it's as expected. Stores, build, debug. Yep. 12 tokens, 7 lines. So I actually think we're close, except there's something about lazy with gotos that's breaking. Or let's go with compute, or compute next token. Do we have a token? Compute next token. If our token is valid, then we start a new token. Go to our start. Start new token. Current rule, none. Current character, character in line, and our line number. Is it valid? No. I don't see any problem with that. Is lazy Um, okay, what about this then? Start new token. Is that why we're not moving on? Maybe. We're not updating. So if we consume a token, but it's not one that we want to keep, we accept we start a new token and then kick out. Try that. Yeah, just about time for some fresh water. Nope, same issue. State 9, accept, accept, accept. Keeping the token. Huh. It's interesting that that's the loop it gets stuck in. Accept, keep token by some rule. Go to lazy pop. If it's valid, we're done. Otherwise, we start over and go back to the top. Start state. If we are done, go to token complete. And things aren't quite popping correctly anyways. Which accept is this? Accept. Lazy go to. Lazy function pointer bind. Oh, lambda. Oops. Switch or function pointer array. Are we even getting where I think we should be getting? That's the question. Especially with these macros. It's harder to trace through those. Blah, 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 ha. Zero confetti. Lazy goto. Lazy goto. So those are the right accepts. Okay. It underscore log. Complete. For back to top. There's just one tiny little thing around the accept function. Oops. This is the last major processing branch for Tokenizer for now. I'm not sure where we've got a mismatch here. Complete. Complete. Should mean it somehow never leaves this state. Go to token complete. If we are done. not begin. Compute next token. If the last token is valid, it should start a new token. List of 9. Complete. Token complete 23. This token is valid. Start label, since this is the first state. Should first ask if we're done. Something small I'm missing. Probably streamer brain combined with way too many carbs and sugars from yesterday. Bill, Steve, does get there, but somehow token complete pop. Now we ask the token is valid, return the token. Then we ask, do we have another token? Where we say start new token. Is start new token not being called? We're done, we call accept. Pretty sure it's part of accept. You start a new token. No, you don't. Are we starting a new token? Well, we shouldn't. It's already done. Here. Ugh. Starting new token. Hmm. Something somewhere we're not going to go to the right place, I think. Ouch. Okay. Complete. So it's not starting a new token. 0 munch. K. It doesn't know what to do with K. So it says we accept the new line. Then we go back to the top. Because new line is not an actual token. So at the top we say go to K, confetti. And the end of string is a thing. So we say go here, accept. Keep this token. Mark it as complete. Jump to the complete code. Then we immediately start up here. How do we not? How are we not triggering this line? We're not actually getting into compute next token again, so accept. Where is accept? Complete. Go to complete. Otherwise, back to the top. We're not doing that. It's being marked as complete. Next token. Compute next token. Oh, okay. I think I know what's going on. And it's here. Token is invalid. Okay, so let me do this. We did the accept actions. I'm going to store current rule ID equals, and we just have to clear this so it doesn't accidentally keep going. I'm going to come back to that. When we hit this complete, right here, if we're done, this accept, I think, is kicking us back up to the top. Current rule ID is not equal to that. All right, we'll try that. That might short it out at the right point. Okay, 12 tokens, 7 lines, correct. Now, we have things not popping when they should, so let's go back up to the top. All right, tokenizer begin, compute the next token, accept, complete, token complete, give me the next token, then compute the next token. So compute next token is not popping out that one more time we need. But these complete and token completes can go away. It's not popping out. After next token. In the accept. If log push, if log pop. Log push, pop. So this has a push and pop. Those should be fine. Begin. Has token, next token, none of those matter. Push. Pop. Pop. Accept or new line? New line just throws it at the top. Push. Pop. Token is valid. Otherwise, we start a new token. Doesn't log anything. So where are we missing a pop here? Accept, keep the token, complete. Next token. Compute next token. It's basically at the end of compute next token, it's not popping like it should. Is there a path? In these gotos. Or we don't do this? Compute next token. Oh, back to top. How is this not popping? Or do I need double pop? Accept. Compute. They both have pops at the right places, I think. Okay, so how about this then? A state. Basically, before any goto, which this one certainly is. So if it's done, like that, and then pop closing brace. If it's done, log and go somewhere. I think that might be it. That should fix our indentation issue. And may fix the last of the other issues. Or lazy goto. Hopefully I didn't break something else while doing that. Okay, I think it's better. Not right yet. Nope, that would not fix it. Alright, find some more go-tos. Here's one. It has an if before it. There's another go-to. Here's another go-to. That one doesn't need one. Hmm. Okay, so I agree with that. What is this state for? Forward slash munch. Go to 11, fine. Otherwise, if we are done, if we're at the end of the file, we can go to token complete. Otherwise, there's an error. Munch, start new token. Pop go to. Hmm. Silly that we're spending this much time on not the hardest part, I would suspect. But if we make our logging more consistent, it just makes it easier to trace the code. These are not the ones we want anyways. This is in batch processing. So over here, how can I get through without calling this one? No. Keep token by rule. Maybe it's in that. Do accept actions. Keep token by whatever. To the top. Lazy. Go to. Push to the actions, then we pop. Next token. Let's get an extra one because we're leaving the loop. This one. They made both. Maybe I just have to pop twice. Because every one of these accepts leaves the current state. Is that what it is? I hope it's that simple. Lazy go to macros. Put two pops in there. How does that not make a difference? I did it in the wrong one. put it in VV test. That might have been it. Because when we regenerated the code, it was gone. Okay, so if this fixes this one, okay, 12 tokens, 7 lines. Run it one more time, just make sure we got it right. Gotos are always a little bit harder to trace through. I think we've got it. 1, 2, 3, 4, 5, 6, 7 lines. 12 tokens. That all looks good. Let's do some quick testing then. Then we'll heat up some more water. That's what we need. Slow day, I'm afraid. 7 lines. 1, 2, 3, 4, 5, 6, 7. It's a blink line, that's fine. 11 tokens, that's fine. One, 2, 3, 4, 5, 6, and a blank. 11 tokens. And here's hoping we didn't break every other combination we've got here. 1, 2, 3, 4, 5, 6, 7 with a comment. So 11 tokens. One should complain about the bad string at the end. 7 lines. 1, 2, 3, 4, 5, 6, 7. Oh, and it did not complain about the bad string at the end. Shoot. Shoot, shoot, shoot. Dadgum. There should be an error here. We broke it. This check, but this check might not matter anymore. If we've got the gotos right, I'm going to put that in prematurely. Trying to fix something else. 11 tokens, 7 lines, 1 error. Okay. Try this out again. Is this the one that breaks it? Let's see how that could be an unterminated token at the end of my input. So we do some bookkeeping. We basically need to know, did we accept a valid token, or are we in the middle of an invalid token? And this does not distinguish between them enough. So what to do? We need to do that, but not that. Rule ID this thing. I need a way to maintain a piece of state, but I don't want to add a flag anywhere. Token, 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 token. Is this it? Which means maybe we can simplify that if statement there at the end. So this 12 and 7. The other one we're mostly concerned with is this one. $11 and 7 and terminated token at the end, so we do get our error just as we expect. Let's test one that discards the token at the end. $7 and 11, all looks good. We'll check one with nothing at the end. So I think this was what we needed. $11 and 7. So I think we can just do a little bit of tidy up here. If done, and not m_token dot is valid, then we can accept, and then we always do the new line in this case. I think that simplifies it a bit. And then our accept, this one doesn't need this. Right, a couple of tests, then we may run the full batch of tests. 12 and 7, correct. Oh no. 1, 2, 3, 4, 5, 6, 7, yes. All right, run these tests manually, and I think we might be ready for the batch testing. One, two, three, four, five, six. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 5, 6, 7, 8, 9, 10, 11. Yeah, because of the comma. Yep, 7 and 11. These should be no different. It's just what's trailing is the question with these 3 in the middle. Okay, so 11 and 7. 1, 2, 3, 4, 5, 6, and a blank. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. How is this 11 10? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, I forgot the period. Okay, 7. Yes. Okay, 2 more manual tests. One, 2, 3, 4, 5, 6, 7 lines. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Yep. Last one. Could also be a 7 and 11 with 1 error. One, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Unterminated. Okay, so I think we've got it. So maybe time to run the full suite of tests. Time./test permutations.py cd back. Really? Test. Oh, for Pete's sake. Okay. CD tools /test permutations. I would like to time it and come back up. There we go. Oh, wow. Okay. Hopefully things just work now. Dispatch, go to process lazy with macros passing. Now we're getting there. Let's see how many other things we broke. I don't think we did. But you never know until you actually run the test. And our tests, there are 11 pieces of text for each one of these passes that we tokenize. I think we're good. I think that wraps it up. So there's 48 times 3 tests. No, something else has failed. Switch dispatch lazy with helper functions or macros. Oh, darn. We did break something else. Switch and process lazy. So switch lazy failed. Switch lazy. Function array lazy. Those were all passing earlier, so I bet it all has to do with that end of text stuff. And we have to differentiate a little bit. Around that trim trailing stuff. Which means we can probably find it in the diff in Tokenizer. I'm gonna have to heat up some water before we tackle that though. Oh. So close. Yeah, I'm like 90% sure if we just change that. Let's see here. What test do we have? We just find this one. Of course, it's not gonna be that simple. Process lazy. Three lines got 4. Okay. Yeah, so basically, we know what to do. I'm 99% sure. Lazy goto is the one weird case. Everything else is done the other way. So this 47, 48. We're like almost there. Okay. Diff output to something temp text or something. Temp text. What we want is to search for tokenizer, which is this one. We don't care about anything else. And what we want is trim, what's here? Trailing, tokenize the trailing bit. Hmm. Okay. Let's try this then. Get show to text, search for tokenizer. Okay. I'm just going to put that there. Where's our else if? Else. This chunk is going here, except that. This. If I'm right, this is the end of the while loop, yes. So basically I have to tokenize slightly differently if we're go to or not go to. Try that. Sure. Just make sure it's working. Hey, G Finelli, doing good. How are you doing? Just trying to wrap up the last little bits of tokenization lazily with gotos, which I think we're just about there. So we're going to run our test cases. Let's see if that fixed it. Fail? Wow, that's no good. They're failing fast too. So probably a build failure. Doing fine. Good, good, good. How's the game coming? You're doing Pong, right? One fail. ASCII fail? What does this even mean? It's not. Enter, leave, fail. This is not helpful at all. I left Pong in an almost finished state, got a bit lazy to finish the text of it. Otherwise, nice. Have you started your next project already? Is that why it's left slightly unfinished? Started a bit bigger game with some new tech for learning, so I'm making an ECS from scratch. Okay, okay. Well, ECS is one way of thinking about a problem. And for small-ish games, it's fine. It's just fine. But it does incur its own special kinds of overhead. If you're doing an inheritance heavy thing, then every overloaded function, which is going to be called every single loop, every frame, is a redirect. It looks it up in a vtable and then dispatches the function. So you can actually end up incurring a lot of runtime overhead just doing that extra lookup. It's not a lot, but if you have a lot of game objects with a lot of overridden functions or virtual functions, it can add up to a lot of performance, turns out. For a small game, it's fine. You're not going to notice it. What is small? I don't know. Thousands of entities. But if you get big, it can be a problem. Another problem can be some processes are more efficient if like memory is next to like memory. So like the physics engine, if your physics data is all in a single array, and then your entities point to that data, then the physics engine doesn't care about the game object. It's just like, I just need the physics piece. If you keep all the physics stuff next to each other, then it can blow through that really fast and not get a lot of CPU cache misses, which you might get in a more object-oriented fashion. So yeah, some more render stuff with textures. Nice, nice. To be honest, for Rust, it looks better because of how Rust works. Okay. As there isn't inheritance, so the change in architecture works better for the language model. Okay. Okay, well in Rust, you're what is it called? Implementing interfaces or something? I forget the terminology. What is failing here? We outputted the project file. Result false. Writing to I actually agree. What is going on here? Huh. Yes, but interfaces do not inherit from, so there isn't a way for parent to child functions easily. Right. And it's quite fun to write. I do have almost a good enough ECS at the moment. I just need to add a command buffer for deferred calls, and it would work for the game. Nice. Yeah, that's one thing I regret doing on my other game is input buffer, user input buffer. I should have done that. I think it would have given me some controls that I don't have, but too late now. Gonna have to wrap that up. -v. Are you crashing somewhere? Like, what is going on here? Exited normally. That doesn't make any sense. The name of the project this time is Corvus. Nice, nice. Yes, we had a discussion about project names. Always fun. Cool. So what's this game? Is it? Let's see here. I can't get any information out of that name. Can't even guess. What kind of game is it? 2D, 3D? Vehicle, spaceships, single person shooter, side-scrolling platformer, so many options. Card game. What is even going on? What is this thing doing? Project file. Here. Read project file. Oh, well, that's a good thing we can check. Cat. No, we checked both of them. They're not invisible. Parse. if output NFA, if output DFA, if output directory. I learned a bunch of new things. Sparse sets, yep. Type erasure, interesting. Entity generation. It's a 2D clone of Darkest Dungeon. Okay, okay. I did like Darkest Dungeon. I like Darkest Dungeon. That was pretty fun. I never finished it. I should go back and finish that. But I think I would want to start over with what I learned the first time I started playing it. I think by the end, I didn't have very good set of champions for the levels that I needed, and I think I underestimated how important area-specific bonuses are. You know, being able to avoid poison or bleed, depending on where you are in the dungeon, was huge. I basically got up to the last level, and I couldn't beat it without retraining everything. So wonder if I just need to start over. It was a good game though. Really like it. Project.write. It exits normally, so but it's not outputting anything, which is truly bizarre. I didn't think I changed anything that would cause it to fail. If there's no this, otherwise, we do this. Maybe this comes out. Doesn't change anything. Confusion. Yesterday was United States Thanksgiving, so I am like full of food and carbohydrates and just tired, so it's kind of a slow day. I'll copy the gameplay loop with some changes to it, but the concept of more like modern soldiers going to planets to steal resources. Nice. That's odd. Did whatever we do just fix a thing? I'm confused. Sounds fun, sounds fun. And now it's just running. Okay, I don't know what was wrong before. Maybe it had something to do with a bad build. I had a flag set wrong somewhere. Very strange. Okay. Ooh. All right. Well, gotos are looking pretty good. We'll see what happens at the end of goto. Darn it. Lazy switch still failing. Read from file. Pass, 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 pass. Yay, it's getting way too many lines in a few places. But it's the line numbers that are messing up. Interesting. So whatever we did, darn it. Whatever we did. Funny how doing games like this is 90% of the time making things, 10% of the time making the game. I didn't even touch anything about the game yet. Yep. No, I've on my other game thing, I've spent like the last week doing little 2D animations of a chalk stick figure. Very little of that time was in code. Oh, it is kind of amazing. So I broke something. Go to if it's not, then it ends the while loop and then does what it did before. These failures, they happen with functions and macros, so that's unfortunate. How did everything else with lazy get broken? Or dispatch switch lazy, functions and macros, character, yeah. Lazy and everything else. Shoot. Is this not what I started the day off with? All right. Get three. Friday, November 29th. Friday, November 22nd. Get stash. Trailing bit. Oh, we haven't checked it out yet. Check out this. This was working at the start of the day. Check out master. Dash pop. Oops. Ugh. I have a question about if you think it's a good idea to make the game fully open source, so anything the game would need to be sold, it would be open source. That would be a beta version. But I would later then get that beta version and add more content to it, like only content and not functionality. That would be a sold copy later. Interesting idea. If your game is more story based, I would say that could work well. So basically, you'd have the game open source, but then you would sell the next chapter of the story. That is a way you could do things, and that's not a bad way to do it. Wow, this is useless. Okay. Source builds debug. That all is as expected. So let's try this one. That might not be a bad way to do it. If you're not adding functionality, that's really the only way to do it. If you're adding functionality to like core game, you could maybe sell those, but you'd have to convince people that the new features are worthwhile. Whereas if you suck them in with one free story chapter on a solid game core, then you're just adding story chapters to it. That could be pretty monetizable. But I am not a marketing expert at all, so like take my ideas with a grain of salt. I'm still not sure exactly how I'm going to advertise this thing other than what I've done with Twitch and YouTube so far. Please work. Oh, I think we might be there. We might be there. Like I said, if I ever picked just one of these build combinations and just focused on that, we could have been done ages ago. But even then, like we're only 16 weeks in, which if you think about it is 16, 17 weekend, like 1 days. So 3 weeks. So we're not even that far in this project. It's just split out over the calendar so long. Ooh. I was thinking like, hey, I made a game, but if you like my game, you can buy a fuller version with more things. Yep. If you want to, you can get the open source and compile it yourself and add content yourself, fully moddable. Yep. I mean, it's always a cool concept to open source things. Absolutely. There are potential downsides. I mean, there's always trade-offs, right? So the question is, what are the trade-offs and what are they worth? Are you willing to pay those prices? So there is an inherent risk of you have a solid game, but somebody else can do the polish and the finish work better. In which case, maybe their fork starts taking away your customers. Option two, maybe it works out perfectly and there is no downside really. Nobody wants to fork it at any meaningful scale, and your game sells well, even though it's the core of it is free. Yeah, I mean, so basically what you're saying is the initial open source, the demo would be open source, but then the final versions would all be closed source. Is kind of what you're saying. That's not unreasonable. In fact, I think Jonathan Blow's plans for his current Sokoban style game is to release all the source with that, even though you buy the game, but all the source comes with it. So I would be curious to see how that affects his earnings for that game. I don't know. When you start trying to mix open source with making money, it can be very difficult because there's almost always somebody who's willing to fork your stuff and do it cheaper, which does kind of undercut earning. I think we're good. I think all of these combinations are working now, which is good. Almost all of the issues were around accept and end of text buffer processing. I think there's 48 tests now, and it looks like we're going to pass all of them. Cool. I would love a people fork, to be honest, even if I don't make money from it, to share with the community. Yeah, that's awesome. That is cool. It'd be basically a donation at that point to buy a compiled version of nice things. Yeah. Yeah, and I think that offering something for free and then saying there's more if you pay, that's not a bad way to run a business. But you do have to make some money somewhere, whether that's a day job or off your games themselves. Like, people got to make a living, so don't think that your programming or your game or your content isn't worth paying for. There was an interesting article ages ago about what the Bagel Man saw or something like that. I can't remember the name of it, but this guy started delivering bagels, and one of the things he found was that if he put in an office a bunch of bagels and things, and then there's a box where you put your money in, right? And he found that if you put just like a shoe box, just a cheap cardboard box out there, people would break into it all the time and steal stuff. And then he found if you put a big, heavy, super expensive metal box with a lock on it, people would break into that too and steal money. But if you put just a wooden box with a simple padlock on it, it was broken into much less. Like he would, so basically, there's like this happy medium of offer something people want, sure, and then make it too easy to steal and people will steal it. Make it too hard to steal and people might take it as a challenge. But if you just make it hard enough that it's inconvenient to try to steal, and then but not so hard that it becomes a challenge for somebody that's of that mindset, then it turns out that less people just bother stealing. Or he also found like people on the upper floors, the management types, the C-suite type of people, they would take bagels without paying far more often than people on the lower levels, the worker levels of buildings, things like that. So it was like, if you want people to pay for your stuff, handing it out for free isn't always the best way to get people to pay for it. Like just requiring some payment says, I think this has value, and that communicates to the people who play the game, this has value to someone, in ways that I think a free offer with optional donations doesn't. That's you kind of saying to the world, here's this thing I made, I don't value it, you can give me free money if you want to. So it's more of a communications thing, setting expectations. For sure, if it's good enough for people to fork and use it already worth money, at least its fame can be used to make something bigger. Yeah, sometimes it's just reputation. Putting something out there for free, as long as you understand what you're getting from it and what it costs you, what the alternatives are, right? Putting something out for free and saying, I'm building a reputation, as long as that's your goal, yeah, put it out there for free. And can definitely work out great. So, all right, journal, we got it done. Fix the macros. We fixed the macros for lazy goto. There was some subtlety. Wow, cannot spell. Around the end of text, as usual. So there are two versions of trailing text handling in lazy. One for goto, one for everything else. All tests now pass. To do. We did it. We did it. We got those tasks done. Get status. Get add everything. Get commit. Goto in lazy processing is fully implemented and tested. Done. Woohoo! Oh, we should go in our performance switches and mark it. Done. Oops, not that one. This one. And this one. Lazy and batch processing are completely done. Oh, thank goodness. I knew this part would be painful. Wait a second. Performance switches is not it's not part of the thing? Really? Git add doc performance switches. And we want to force that. I do want to add this one, thank you. Huh. Didn't realize documentation wasn't being tracked. Adding new doc file. My bad. Okay. Phew. Lastly, there isn't much in the space I'm working with. Rust and all is not the goal of people, but there is people, so if my content can help the next guy learning, that would be amazing. Yeah. Actually, for learning, that's exactly right. The best way to learn any language is not to read the manual. Well, that's not true. The best way to start learning a language is through examples. 100%. Obviously, if you want to get really good at something, then you read the manual. There's almost always subtleties in the manual that people miss in the simple examples. But a reasonably scoped example file is definitely a great place to start learning a language. All right, we did it. Oh. All right. We are pretty much at the point where we need to start doing that. And then this. Ah, yes. Good. We're getting to the mind-bending parts. So far, everything is just complex for good reason, but not the right reasons. Okay. We're going to pause here. I'm going to go heat up some water. Heating water for yerba mate. Be back soon. Yeah, I'll be right back. And we'll carry on with the next stage of our work here. So I'll be back in just a minute. Hold on. Okay, I'm back. Sorry about that. Can only run so long without refilling here. Okay, so I keep putting this one off. Just keeps going longer and longer without getting done. And this one is not hard. We can do both of these pretty quick. I don't really feel like doing this one today or that one. I'm not even sure this is worth it. But these two we can knock off today. Let's get those done real quick. But then I think we're going to start on this one. We're not going to get very far today on this one, but we might have time to start it. Okay. All right, weeks 15 and 16. I don't remember what those dates were. So let's go take a look here. Documentation metrics input weekly. 16. So 17 was on 11/02. I don't know. Let's go back a ways. Output to temp.text. Reload. And what we're looking for is 11/02. So November 2nd. Did we not commit anything on the November 2nd? 9th? What week are we even on in here? Holy smokes. Today is the 29th. Which means we didn't log anything last week either. Oops. So 16. Cache video times. We did not do a good job of recording things lately, have we? Okay. 17/22. Or no, not 17. 18. 11/09. 16. 19. Oh, okay. 11/16 would be 23, and then today would be the 29, 22. Yikes. I need to look at a calendar apparently. Can't keep track of this stuff. Eight, 15, 22, 29. And 1. 10/25. Okay, so the 1st, the 8th, 15th, 22, and 29. Okay, so we need 15th and 16th, which is 10/25. So if we go all the way back to October 25th, the last commit on that date is this one. And then I need to get the time, which is not hard because that's all in YouTube. Playlists, compiler from scratch. That's not helpful at all, is it? Videos. Okay. So 10/25. 10/25 was 5:52:58. 5 hours, 52 minutes, and 58 seconds. Now 11:01 we didn't commit anything. Which I think means this was at the start of my stream. So this would have been the equivalent of the last thing we worked on the week before. So this is 11:01, 4:21:20. 4 hours, 21 minutes, and 20 seconds. And the 8th, we've got a commit already for the 606.11. 606.11. This is more for stats gathering than anything. It's not like important, but you know, better to keep up on your record keeping than anything else. 11:15. So on November 15th, the last thing we committed was this one at the end of the day. And the 15th, 6:01:45. 6:01:45. All right, we're getting there. Then the 22nd. Was this one. And that commit, that was 5:58:11. 5 hours, 58:11. I really do like how my videos record for me how long things take. Like, it's always easy for me to go back and look at how long a project's been going. This will be today's. But I don't know how I'm going to do it if I'm not streaming on a project. How do I keep track of my time very efficiently? Probably just have to be more conscientious about that sort of thing, huh? Okay, well, that's that. Journal, we did that. Updated metrics in weekly.json up to today. All right, easy peasy. Updated old hashes session times in metrics input file. Okay, easy peasy. Journal. Text buffer should check if the report error function is null. Let's go do that. Text buff report error function. Text buff implementation report error function. If report error function is null, log error, no report error func was provided. Maybe log warning. Text buff implementation. Dot read file. Port error function is null. Log error. Not equal to null, do that, otherwise log error. Thusly. Ugh, yeah, this is gonna balloon a little bit. Heyo, how's the compiler going? It's good. Actually, we've got all the different build options complete. We now do goto dispatching in lazy token processing, I forget how many tests passed now. Look at all those beautiful tests passing. So that was 144 tests, because each one of these three is within each test. So yeah, all passing. We're picking up a little bit of technical debt right now, and then we'll start the fun part. This is where things get weird. Not weird, but harder to conceptualize. Maybe it's not even harder to conceptualize. It's just more fun, I think. So we're just doing a little bit of tech debt here. Log error. Put this in here. Else. And how was your stream? What did you work on today? Yeah, port error function's not null. Otherwise, log error. If this is the case, otherwise log error. We have 3 different file open methods, so yeah. How's your stream? How's what is it, calcium? How's calcium coming? I was working on my text editor. Oh, right. I was organizing my scripts for Pong. Yep. Getting ready to add some levels. Ooh, so like, what kind of variation between levels are you going to do? Just speed? Or you got something crazier planned? Different paddles, different powers, different balls, maybe? Multiple balls. So it'd be kind of like a pinball where you get the extra ball thing. I don't know, so many things you could do. What am I doing? We could make this so much simpler. Oh my gosh. Why are we doing this? Not going on autopilot, not thinking. Problem when you don't think. Luckily, not too hard to fix. Okay, report error. Right now, mainly just how aggressive the enemy eye is, the aesthetics. See how far I want to go once that's done. Nice. Nice, nice. Sounds good. Okay, here's what we're gonna do. You ready? I'm gonna duplicate this. I'm gonna take a VA list args and a VA list args. VA end. That's basically it. So we print out the first piece, we print out our formatted string, we print out the last piece, flush. Error and warning. So then this thing, instead of this, log warning, format and args. Same thing here. Log error, format and args. There we go. So that should help a lot. And then in VB, in text buffer implementation, if report error function is not equal to null pointer, that else log error message and args, and we are done with that, and hopefully it just builds and runs. The amount of error handling having your tokenizer puts mine to shame, haha. Well, my problem is I do everything boneheaded in the wrong way. So like the more error messages I print out, the faster it is for me to find my stupidity. It's defensive. I don't want to have to hate myself. Okay, typo there. That's not hard to fix. Text buff, and I still don't think I have enough. It's logging errors to console. Haha, faux show. Yeah, the problem is when you start thinking you're too good. I'm gonna get some food real quick. Cool, cool. Take time. Food is important. I like food. Overloaded function with no contextual type information. Fine. VB proj parser. Log error v, warning v. Then text buff impl. And do it that way. Sometimes I guess it can't tell the difference. Hmm. I don't think. Hmm. Oh. Order matters. Order matters. All right, we run a simple test. Looks good. Now I can run the complex test. Just make sure we didn't break anything. Go back to our make file and restore some of these to the good old-fashioned switch. Go to. I just conceptualize them in this order. Find iterator, find macros. I tend to go for functions first and then we come back to macros when we feel like it. Lazy. Batch. So these are basically an order of how I conceptualize the complexity of the problem. If we batch process, it's simple. If we do switching, that's easy to read code-wise. Bind versus lambda, I don't really care. Iterator, this is probably easier for some people to read. I don't know. It doesn't make that big of a difference. But functions are easier to look at than macros. I don't really care about that one. So we're just putting things back to a standard default for testing against. But so far, it doesn't look like we've broken anything with that change. Which means we'll have worked on enough technical debt for the day. Also almost to the point of using our own PDFAs. That'll be a fun question mark detour. $48 of these tests. 15 more to go. But we have high confidence that we're not breaking anything. This is over a 3,000 line file, give or take. Oh, 2,200 for some of these tests. That's not bad. What we need to start thinking of. I'm actually not that sad by this. I'm not that sad by this. That'll be an easy one. Maybe. Okay, good to go. Journal. Text. Buff. Impl. Checks for report or func. And just logs. Let's see here. If null, logs a warning and proceeds. Logging to console instead of reporting the error up. Okay, tests all pass. So we didn't break anything. That's important. Check for report or func. Oops, cannot type. Added check for report error func in text buff impl. Good to go. That's good. We've been wanting to get some of that tech debt out of the way for a while now. So journal and to do. I don't really feel like doing this part yet. I think this is tech that we can put off. It doesn't really affect what we're doing yet until we get to multi-file. Then it's technically possible that you'll have a file with the same name in different directories. But so far we're doing single file testing, so not worth pouring effort into that now. Okay. I know for 100% sure there is a bug in our code which we just haven't manifested yet because I haven't done it on purpose, right? And that will be DFA transition ordering resolution. So I've got that bookmarked just in case. When it pops up, we'll deal with it. But for now, we're going to ignore it. Just like we should. But these dependencies are done. Well, sort of. The parser portion still remains down here. So not just the project file, but also the tokenizer definition file. Okay. Okay. Blah, blah, blah. Anything else we want here? Once we hit this bug, deal with it. 2 options. Okay, we'll get around to those eventually. Okay, our project file. We need to generate a tokenizer for our project file. If we go into VV project, parse a text file this is really bad, right? We don't want to do this. We don't want to scan things in particular orders and require different things. This is not great. It's not my favorite. Result, etc., blah 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 blah. You have a potential issue. I think I know how to get around it, but we're not going to worry about that just yet. So we want to replace this thing, this code, with a different parse method, which uses our tokenizer. We're going to generate a tokenizer that parses this file. So let's start doing that. Let's go to vv.vvproject. Let's see here, vvproject.vvproject. All right. We want these keys. So something like keyword we'll keep, and it's one of name or encoding or tokenizer definition file or a parser definition file. Those are our keys. Then we need these ASCII things. Let's see here, char ref. These 3. vvp.vvp. So these are encodings. We will keep those. They are ASCII or Latin 1 or UTF-8. We need a tokdef. Regular expression to capture a file path or name. Is that good enough? be good enough. Blah, blah, blah. Let's see. Okay. So that is that. Then we're also going to need a VV project.tokenizer, which will say what's allowed in a tokenizer file. So for example, our test.vtoke .vtoke, we're going to require that it be a token name, which we will keep, and must be uppercase, underscore 0 through 9 star. What else do we need? We need a action, which we will also keep, and it will be one of discard or new line, or what else? I think we just assume keep. I think that's it. Keep becomes our default. Line, space, white space. Unfortunately, regex is a bit of a pain. We want to go from something to the end of line. But just anything which is not a new line. But that's the lowest priority. Therefore, we can steal line and white space. And this comment as our discards. And this will come in very similar to VVP dot VVP. So now we're making config files that are going to write out a tokenizer, which will define our next generation of config files. And I don't know how well that's going to work. Generate tokenizer for VV project and VV Tokenizer definition file parsing. Let's make those two different line items. They are different things. Generate tokenizer for VV Tokenizer definition project. Definition file. Okay. Part of me, let's see here. So VV project. When we write these files out, right. We put this VV in front of it. I'm not sure I want to. Because yeah, that means that our test needs to be told nope. Temp proj file. Is nobody using that? We should clean those up. Then what are we outputting? Oh. It's also called test. So if we're looking for VV test, that's probably going to not work anywhere. We aren't doing that. Destination directory, I'm pretty sure we're using it elsewhere. Let's... Really not using test.exe? VV test parser, not really. Okay, let's just get rid of those then. This is not that one. VV project .vtoke. My bad. So this is rename file and buffer. This is vtoke.vtoke. This one is vvproject.vtoke. Which means we still need a vvp.vvp test.vvp. It's basically this, except this is vv project. I'm not sure UTF-8 is the right answer yet, but vvp.toke. Actually, the project file can be UTF-8. That's fine. The one I'm most concerned with is vtoke.vvproject, vv tokenizer. Tokenizer definition, which needs vtoke.vtoke. We'll stick it at UTF-8 for now. Okay. Then, makefile. Let's see here. My tokenizers needs vvp.vvp, vvp.vtoke, vtoke.vvp, and vtoke.vtoke. And it requires a debug, probably. Whereupon we can run // basically this, except debug build. Not sure, there's a lot of different ways we can go with this here, so then we do it as this dot o, which needs I don't know. Let's not overthink it. Let's just do this. So vvp vv vv toke vvp. All right, let's just try it. Compile. Clean my tokenizers. Let's see how bad it goes. Good progress today? Yeah, we're done with the goto based implementation. We cleaned up a little technical debt, and now we are trying to start replacing our own config files bad processing with our own tokenizers that we're generating. Obviously, it's not quite working right, but we are getting there. Let me just do this from the command line just to try it out. Okay. -o source. Okay. Then the other one we want to do is toke BVP. In theory, that did useful things. Is it true? I don't know. Okay, well, I didn't like that. Venomweed is the name of the game engineless, or are you using no engine? No, I am using no game engine, but I forgot to hit the OK button and change the name of my stream. Oh my gosh. Sorry about that. Yes, I'm using no game engine. So that project is Monday through Thursday. Yeah, sorry about the not updating the label. What we're doing Monday through Thursday is building a game with no game engine. You have 4 dependencies, or 5 depending on how you want to count it. I use GLEW, so the OpenGL extension wrangler comes in with the GLFW, which is the GL function wrangler, right? Which gives me basically my window handling and my hooks into OpenGL. I've limited myself to OpenGL 3.3. No extensions, just to keep it bare bones and minimal. And then I have FreeType 2 for my font rendering, which I want to replace, and GL Math for math. Hey, Venomweed, thanks for the follow. I'm a Chad. Thanks. So yeah, 4 dependencies. That's all we allow ourselves. And yeah, we're building that game. I can give you a quick preview, not preview, but we can run it real quick. We're pretty close towards the end of the stream. But we can run it for you once. That should display on stream. Yeah, that's showing up. So it's a word deduction game. And you guess words. Interesting. And then you try to deduce what the letters are and guess the word. So I know there's 4 letters. Ultra Demon, therefore these ones are out. Laced Rhinos, therefore UMT is out. Proud Lines. R or E, that's interesting. OADS. BD gets me 2 new letters. AED, so that doesn't help much. Vlogs. So we can eliminate all those letters, which means we know these and these, not that, nor those. Vlogs, Jacks. So it's J or K. So this is something like naked. Well, the letter is K. But then we also have these little doodads we've been working on lately. So our little archer dude who walks left and right. If you right click on him, he draws his bow. Then you'll aim it. And then we don't shoot yet. That'll be happening next week. What word is this? Caned, naked, taken. Huh. Anyway, that's the game that we work on Monday through Thursday. Let's go easy. Yeah. Except I'm like so hopped up on sugars from yesterday. United States Thanksgiving, so I ate a lot of pie. Yeah, I call these little things on the chalkboard. There's other ones we have besides the archer. We have like a little bouncy ball and the bubbles that float around the chalkboard. Just little interactables for people to fiddle with. What is this word? Need. Okay. Oh my gosh. Wow, that was really slow of me. Anyway, so that's the game. Oh. We have a cool little replay mode, so you can watch your games. Yeah. If you have any questions, let me know. Friday, I take a break from game development and do some compilers work where we're doing everything the wrong way on purpose. Because I want to. If you want to build a compiler, the tokenizer is not that hard, but we've already spent, what, 20 sessions writing a tokenizer generator. Because I kind of like that NFA, DFA stuff. Non-deterministic finite automata and deterministic finite automata. We like doing those sorts of things. It's pretty fun. So what we're trying to do is get this thing, generate these files the way we want. And it looks like it might have -o source, -o source. And we're at an interesting point where we are using our own tokenizer generator here to read in a project file so that it will output a tokenizer for our project files, and the same thing for our tokenizer definition files. So if you look at like test.bv project, you know, it's a test thing, it accepts UTF-8. We support UTF-8, ASCII, and Latin 1. And then here's where you go find your tokenizer. So if you want to look at that, test.btoke. Here's our tokenizer file format for now. Once we replace the parsing of this file with our own, we'll start making changes. But here's the name of the token type. Whether you discard, count it as a new line, or keep the token, those are right now the only 3 actions. And then the regular expression that we compile to a DFA ourselves. That's what we're working on. So if we do this, it is writing out something for us to use. So yeah, like I said, let me know if you have any questions. Always happy to talk. Master Lich, in your makefile, do you have a target for every individual CPP file? Probably. I think so. I probably don't need to in a lot of cases, but for the cases I do need it, and I just got in the habit of putting them in there. It keeps me honest. So if that's the case, we should be able to see our VV project parser which of course is not going to be a complete thing yet. There's the header file, a little bit on the minimal side, not too bad. Where most of it is taken up in the definition of the actual token that we pass out. String ref and text buffer. That's why those are forward declared. Okay. Then VB project parser.cpp contains everything else we need. And like I said, we're doing this all the wrong ways. Like, you're making a language, or is this a compiler for something else? So we're making we will make our own language eventually. We're still early days. Like, let me give you the quick rundown. What usually happens is you take a code file, you dump it into a compiler, which does tokenization. Tokenizer, sometimes called a scanner or a lexer. You might hear all of those terms. I call it tokenizer. I think that's more descriptive. And out comes, let's see here, tokenizer is a process. Let's go ahead and mark it a little bit differently. Outputs a bunch of tokens, which then goes into a parser, which takes those tokens and puts structure on them, right? So this might be something like, 1, 2, 3, whatever. The parser takes that and puts it into a structure, and out comes an abstract syntax tree, which goes into semantic analysis. And when I say AST, so let's see here, maybe we can just do an example. 1 plus 2, right? Then the parser takes that and it turns it into something like this, where it's plus / / is not the best mode for typing in random stuff. 1 and 2. So it imposes structure on it. It says, I know what 1 means, I know what plus means, and I know what 2 means. So the plus must relate to 1 and the 2, right? Then we go to semantic analysis, where we get basically a check on this and say, what type is plus? Well, we don't know unless we know the type of this. We don't know the type of this. Oh, we do know what 1 and 2 are. They're integers. So the type of plus returns an integer as well. So you're going to get an updated, detailed syntax tree that'll say, here's how things relate to each other even more. Then you go into, optimization, intermediate code generation, interpretation, transpiling, whatever, right? So while we will eventually make our own language, what we're at right now is at a different point. We're doing this, where we're writing code. Oh, okay. Let's do it down here. Good heavens. Put that back. We're writing code that we put into a compiler, which outputs a tokenizer generator. And into that tokenizer generator, we feed config, some sort of configuration, which is this one, vvp.vtoke. That says, here are the things I want to do when I tokenize. And out will come, that will output a tokenizer code, which we then compile into our tokenizer, this piece. So basically we're writing all of this to generate this. So we're nowhere near language yet. Like, until we get through semantic analysis, you can't really say you have a language, in my opinion. But I do have a plan for that language. Well, parts of plans. It's not complete. This is all for fun. But we're way back. We're before this stage. Now, if I just sat down and hand wrote a tokenizer, it would not take me anywhere near as long as this mess. But we're just having fun. You made it so much simpler for me, thanks. Yeah. Yeah. So yeah, if you have any questions, let me know. I'm always happy to explain just about anything at any level of detail. Um, Otherwise, what I usually do is I just write code and stream of consciousness talk while I do that until somebody asks a question or has a comment or suggestion. Like I said, I'm doing this all the wrong way. This is not a model for you to follow if you want to write a compiler. But I like this piece of the puzzle. I think it's a fun project. A little different from what most people end up doing. So there we go. So what we were looking at was, and it's even worse than that. Like, not only is this not a good way to build your compiler, you should just write your own tokenizer. It's not that hard. It's basically a loop over the characters. And when you get a character, you say, "Oh, I know what to do with this." Like, so if you get a number 3 as your character, you're like, "Oh, this is probably an integer." Then you go into the parse integer function, which keeps going until it runs out of integers, right? Or if it hits a decimal, it's like, "Oh, this isn't an integer, this is a float. So let's go to the parse float method," and it finishes the thing off, right? It's not that hard. Anybody can do it. So yeah, not only is it that, it's actually worse than that, because what we're doing, if you looked at the VV project parser, is there's all these pound defines. Everywhere that I thought I had a choice for how to do things, I implemented it in all the ways. And then you use build define statements to choose which combination of things you want to do. So do you want to dispatch using the DFA state using function pointers or switches or a function pointer array, or do you want to use gotos? Like all of this code, like there are gotos in here and labels. Where is it? We do our helper functions in functions and in is there a benefit? Possibly, which is one of the things I want to measure. Go to. So we can talk about that. So here it is, the goto method. Like here's a label. Some of the things go to the other states, goes to the complete token, etc., etc. Is there a benefit to doing a tokenizer that way? Yes and no. If you want to get something done, it's almost always faster to just write the tokenizer yourself. A tokenizer generator basically means I don't have to write a bunch of code over and over again that I already have written before. It takes away means I can quickly define a simple tokenizer rule for JSON, maybe. That takes me half an hour instead of writing for several hours. It might be faster for developer time. I think with the way we're doing it, where we have a million different build options for performance check testing, I think I'll be able to find out how much each of these things affects the output. So if we go to performance switches, this is the documentation for it. We have different methods for open, like how much does it cost me to use a system open call and system read as opposed to a library function for open and read, or using a modern C++ file stream, right? I have different methods for iteration. Which one, how much does it cost me to use these different choices? Different dispatching methods. How fast is goto compared to just using a function pointer? How much does it cost me to use a switch statement? I don't know. I have some intuitions about how these rank up, but I haven't measured it. So we'll be able to do a lot of testing with this because of the way we've built it. So this is more for education than for, let's build something super awesome. This is so educational. Thanks. Yeah. So like I said, if you have any questions, let me know. But we've got all of these combinations of things done now. So we can actually parse using, it's 48 different build combinations, and each of those we build in UTF-8, Latin 1, and ASCII to test against. So that's a lot of different tests we've written. Like I said, a bad way to do it, and we're doing it even worse than that because of all of this. If I wanted to get something done, I would have picked probably fopen. I would have picked this one, character advance. So basically, I run the iteration myself instead of using a nice wrapped up C++ iterator class. Dispatch switch, it's not necessarily what I think is the fastest, but it's the easiest to implement in terms of like readability, human use. I'd probably use lambdas. I'd probably do process batch. The workflow for that is just much easier. So the way that I structured the code, and I'd probably use functions just for more readability. But I think, it's worth testing. How much does helper functions as functions versus macros cost me? So when you see this file, and you see that it's, 4,500 lines of code, basically all of these states are implemented 3 different places in this file. So it's artificially inflated, the size of this file. Once we've done good testing on performance, we'll eliminate all the dead branches that we don't care about anymore. And that'll shrink this file by probably a third. Yeah, we've got all the helper functions as both functions and as macros, etc., etc. You plan to share code in the future? At this point, no. I do not put code on GitHub. I don't, or at least nothing significant. Like I've got some random number generation stuff on there. Doesn't really matter. But I'm not going to feed into the AI training data sets. Now, people have asked for individual files and been like, oh, can I see your log file or can I see your this file? And I'll send it to them. It doesn't matter too much. I'm not like, it's not secret, but I'm not going to feed the AI training. I was thinking the same thing. Yeah. Yeah, I don't mind sharing how I do things and explaining what I do. But this is like just a fun project. And who knows, if I make it really fast, maybe I can sell it or something. Yeah. Yeah, yeah. I don't remember. There was like two different files people have asked me for. One was my logger, because I didn't really show it on stream. I was like, hey, I'm using this logger that I wrote. And they're like, I can't follow your code. I'm like, oh, well, sorry. Here's the logger, I guess. It's not the interesting part of the program. What was the other thing? Somebody else wanted to see a file. I was like, that's fine. I don't care. Help yourself. I mean, there are others too, but who will stop them from scraping public repos? Yes, exactly. Always, always. And when you say public repos, you mean every repo that's stored online on somebody else's server. Whether you've marked it private or public, they're scraping that sucker because they own it. That's just part of the way the world works, I'm afraid. So in theory, we have those 2 tokenizers we're generating. Do you use Git? Yes, I do. So let's see here. Where am I at? Yep. So I have a Git log. And go back for months and months, see what we've been working on. But yeah, I use Git. It's all local on the public internet. I mean, yeah, exactly. On the public internet. Yep, exactly. Yeah, I use Git, but it's all stored local. I keep it on a external hard drive. But yeah, just I think I don't know. There's a lot of different ways this could go. Like I said, I've written tokenizers that are all sorts of different styles. Like the good old Python based, hey, for each line in this file, split the line, and then the first word is a command, and after that I can deduce what the arguments are, and just it's not robust in a lot of ways, but for fast and dirty special domain specific language, that kind of thing is fine. Right now we're using scan, right? We're going to replace this with our own stuff, but you can use scan or fscan. You can use Python tokenization, but I think mine will be faster than all of those. I think mine will be faster. We'll see. I have a whole bunch more features I want to add. There's some things I want to do with PDFAs, push down find out automatas. There's a bit I want to do around dispatch order prioritization that could be, I don't know if it'll save me much time in the end runtime, but it's an idea worth exploring. So yeah, lots of work still to do. Also, now I think about it, that's probably the main reason Microsoft acquired GitHub back in the first place. Well, and now they're starting up nuclear reactors so that Microsoft has enough power to run their AI training server farms. Isn't that ridiculous? Ridiculous. Yep. I hope they spend billions on AI. Because right now, the road they're going down, I don't think it's the answer. It doesn't solve the problems that need to be solved. Oh, my back is sore. Okay. Do you think AI can replace developers? Ooh, we had a bit of discussion about that earlier. Can AI replace developers? The current round of AI, so LLMs, large language models, I don't think can replace most developers. Okay, it's an insult to AI to call these individual components AI. Yeah. So the problem with an LLM is that an LLM is strictly imitative. You feed it a huge amount of data and label it, and then you say, when somebody hands you these labels, guess what the most people would have put in here instead, right? So what's the next pixel? What's the next word in a sentence if these are the tags, right? It's making a prosthetic and calling it human. Yeah. But all it can do is imitate. Like, it doesn't create new ideas. It doesn't take two ideas and associate them in a new weird way. That's still so far a strictly human process. What I think AI is doing is there's a human learning curve. So if you want to say, let's do art, you start off as a crappy artist. You're a horrible artist, but you find somebody that needs a job done for $5, right? And you do it for $5, and you get paid, and you learn something. And you do that thousands of times over, hundreds and thousands of hours of practice. You get better until you're better than an AI ever could be. But now we've taken the cheap art and handed it to the computer. So how does somebody who wants to get good at art get paid to learn art? So if you want to be a human who's significantly better and more creative and interesting than an AI, well, the only people that can afford to practice their art that much are filthy rich. That's it. You've just removed the ladder from that difference between the AI can replace low quality artists to, well, now there's no reason for a low quality artist to become, no, there's no path for them to become good. And the same thing's going to happen to developers. It'll be like, well, we can replace all the web developers because frankly, web developers don't think creatively mostly. Most web development is, here's some HTML, here's some CSS, and then we want a JavaScript thing that push the button. It's like, wow, that's not interesting code. Well, we can replace all them, yeah, but now they can't get paid while they learn more. You've just replaced them. You've pulled the rungs off the ladder. So who can afford to now become a good developer? Who can afford to peel back the layers of abstractions to learn more and more? Well, nobody. We've added another layer of abstraction, which is so opaque you can't understand it. That's what AI is going to do. Even you can't replace them reliably. Yeah. As of right now. So let me backtrack a little bit. What LLMs can accomplish is amazing compared to where we were 10 years ago. Absolutely astonishing. But it still is not creative. It is strictly imitative. So what I suspect is a couple of things. One, the LLM is going to become the interface between whatever the next generation AI thing is. It's very good at taking in human prompts and returning something that's more or less understandable to humans. Great. Well, now, where's the creative part? That's not there yet. So I think that LLMs will be that interface. Two, I think that LLMs don't grow exponentially as you increase their training data set sizes. I think it's a logarithmic curve, and I think we're over that hump. I think you double the amount of data you feed in, and you're not getting as big of improvements in quality as you did 5 years ago, 3 years ago, 2 years ago. I think it's slowing, and I think people are going to start realizing that. So you've scraped the entire internet, and LLMs are about as good as they're going to get, maybe a little better over time, but not the jumps that we've had. Where are you going to get your next order of magnitude size of data? You've already scraped the whole internet. Let's see, it's a better search engine. That's what I use it for. That's all. I refuse to use the AI results because what I've found is that when I want a good result, the AI might spit some stuff on the screen, but if I just scroll to the top hit underneath that, it almost contains verbatim text what the AI spit out. 90% of the time, I don't use the AI results at all. I'm like, nope, I'd rather get it from the source, thanks. So, yep, AI, always fun. So, yeah. But the NVIDIA guy said it will replace devs. Yep, it probably will. It'll replace crappy devs. You'll replace crappy devs with a fairly mediocre AI. The guy selling drugs says it's not harmful. Hey man, the first hit's free. I think it will replace some devs, the ones that aren't doing anything interesting. But anybody working on something interesting finds that AI doesn't have vision. It can't see ahead, it can't think. It does what it's told, nothing more, and it imitates. Which means when they generate code that they can't, and then it has problems, they don't understand why. Well, I told it to make this component and it did. I told it to make this component and it did, and I glued them together, and now there are strange interprocess problems, right? Always a problem, because the AI can't put those two pieces together and say, oh, now I understand what you're trying to do, and I need to make some modifications to the first part to make it compatible with the second part. It can't do that. It is impressive, absolutely, but it's not fixing the problems I have with programming. The problems with programming tend to be we've added too many layers of abstraction and people don't know what's happening anymore between code and the CPU. It's like the new hypertrain after NFT and crypto. Yep, exactly. It's just another investment bubble. They've poured millions of dollars into AI, and they made some improvements, but it hasn't generated revenue for anybody yet. So much investment without a plan to monetize by adding value to anything. So the search engine now has an AI that gives you an answer. Fine. How did that generate that money? Not worth the millions and millions they poured in. Yeah. So many good, interesting ideas, but it's not enough to make it change the world, I don't think, in the way people think it will. Yep. So let me think. I think, where are we? Oh. So we've added some project files. We don't really have time to test it. I've got to get going. It's probably getting close to my dinner time. It's going to kill ads too. Yeah, their own income. They're kind of shooting themselves in the foot, and they're replacing what's on the internet with more and more AI stuff. You're looking for an image, well, now a whole ton of the results coming up are AI generated. You're looking for, content. Now it's AI written articles. It's garbage. It's all garbage. So I don't know. It's too bad. It's too bad. Like I said, I think there are going to be a lot of investors very, very salty over the next few years, 5 or 10 years. Thanks for streaming. I'm glad I found your channel. Thanks. Me too. Hopefully you come back on Monday for game development. We'll try to make the archer shoot that arrow next week. The game itself is more or less complete. Some polish, some more doodads, things to fiddle with. Release probably late December, maybe January, depending on how long it takes me to get the store done and the web page. But yeah, thanks for coming in. Thanks for the chit chat. Always appreciate a good conversation. And see you around. You have a good one.